in all the nodal centers. And today we are on the last day of this course, 1 week course on power electronics for renewable energy system. So you would have seen many power electronic systems, the renewable energy systems, how to connect it to a grid or how to power quality improvement in those things. And all these things we have just seen all these days, how to connect these to the smart grid or what are the power electronics involved in smart grid. So today's we have our expert Kuldeep Singh. He is a research scholar and already he had taken a lecture. So I think no introduction is required for him. So today he will be just giving you an insight on the MATLAB modeling side, where how to generally start with a MATLAB modeling. What are the ratings you have to fix on this, and how we will design a grid or something like an electrical power system, and how will we add generators to it. So then how to add an inverter, because an inverter is surely required whenever a renewable energy source is there. It may be in the form of a DC, it may be a wind, it may be, see, wind also, what you do, you just convert into AC to DC, and then only again you give it to an inverter and connect it. So if it is a fuel cell, wind or PV, anything, you require an inverter. So he will just give you an insight of all these things, how to connect a inverter to a grid or how to design it. All those portions will be covered by him. And for the nodal centers, I have some announcement. I think all the nodal centers are listening. For the nodal centers, we will be having our valediction at 12:45. Okay. So the nodal centers, once again, please listen. We will be having our valediction at 12:45, being Saturday. Many people here also want to leave, and it's a holiday here. So we will have the valediction at 12:45, and I'll be just asking feedback from your end. So you have to just give the feedback at the nodal centers, and here the participants, I'll be giving you the certificate, and we'll be taking your feedback. So all the nodal centers, I think all of you are listening. Once again, I'm just repeating. We will be having our valediction at 12:45 at like today 12:45. So all of you, please be ready for it at 12:45. I want all the coordinators to be there. So that is the thing. And one more thing. Once again, I'll just announce that all of you you would have taken the attendance like morning and afternoon. So today also, for the afternoon session also, because it is afternoon session also, we are winding up today itself. It's a valediction only. So all the 8 sessions, your signature should be there. Those who are lagging in attendance, please, there itself you can write it down that certificate need not be given. So the coordinators may know that who have attended the session fully. So accordingly, the attendance sheet, please send it to me, like the scanned copy of the attendance sheet by Monday. Okay, all the nodal centers, the list of participants, I have sent you an Excel sheet. So I want the list of participants in that format along with the attendance sheet, because here now they are a little more strict. They will be just seeing the attendance sheet with the list of participants, and then only they'll be giving you the certificate. So I just want to start the process of certificate on Monday itself. So I request all the nodal centers to please send me the list of participants and the scanned copy of the like attendance sheet of all the 5 days. Okay, first send me that. That is the first thing what you have to do. After that, the hard copy of this list of participants, list of participants, the attendance sheet, and the coordinators and ancillary staff receipt. So many of the centers, they miss that. They just send all these things. They don't send the receipt of it. Until you don't send a receipt, we will not be able to process it. So hard copy of, so that you can just write so and so was the coordinator for this course, and an amount of 2,500 may be credited to his account and his account number. So now checks will not be sent. So we want your full account number, your bank details, and the IFSC code of the bank detail. Okay. Similarly, below that itself, you can write the ancillary or the supporting staff for so and so person, and amount of 1,500 may be credited to this account and their account number also. So both the account numbers, or if you want it commonly to send it to your college ID, college bank account, then you can give the college, like both of them 4,000 can be credited to this account. So now we don't send checks or we don't send cash. So please, all the nodal centers, give us your bank detail. The amount will be credited to your bank detail, sorry, the detail what you're giving, and 10% tax will be cut. So this also many times the centers, they have a doubt why this amount is cut. And for the government colleges, you can even send the other receipts like tea and lunch, and the participants who have come from like outside, you would have filled their TADA form. So the government colleges can do that, or government like participants from government colleges, they will be getting the lunch and accommodation thing. So those, for those people, you can send us those bills also. So this is for all the coordinators. I think we're now one more center is connected. So once again, I'll just repeat it in a short form. All the, like, since one of the other center was also connected now, the valediction will be at 12:45 today. So all of you, please, the coordinator, we want feedback from you. So and from some of your some of your participants. So please be ready at 12:45 for the feedback. And at 1 o'clock, we'll be finishing with the valediction. And like, once again, I'm just repeating what are the things I require on Monday. I want on Monday 100% all the centers, I want your list of participants as well as the attendance sheet. So just a scan copy of the attendance sheet, you can send it to me so that I can process the certificate. So all the nodal centers, once again I'm repeating, you have to send your list of participants and the scanned copy of your attendance sheet. And in attendance, if there are participants who have less attendance, you can just write it by then. Certificates will not be given, so the coordinator itself can do that. Okay, only those who have more than 90% attendance will be given with certificates. So please see that the coordinators, those who have not attended fully, you can just cancel out their name. This is one thing. After that, on Monday itself, please send me all the bills. There is a receipts, as I told you, for the ancillary staff and the coordinator, the 4,000 amount what you get. Just give the bank detail in which we have to transfer with the IFSC code. You have to send the hard copy of that, the list of participants, the hard copy of the attendance sheet, the original attendance sheet, and all these things has to be sent. And please do it immediately on Monday itself, because as you all know, we are in the end of the March. So March, we will the financial year is ending, so we will be closing with all the bills. So if it comes late, then it will be a problem for you as well as for us. So I kindly request all of you to send all the bills or the receipts or everything by Monday, like by the next week itself. I have to get everything by next week. Okay, so now I just hand over the session to Kuldeep.
Good morning, everyone. As you already know, my name is Kuldeep Singh, and I'm a research scholar here. Uh, Past 2 days ago, we have discussed about how can we connect our EV system, electric vehicle system, to the grid system, and what are the components that is required in that in making an EV system. Today, we are going to connect our EV system to the grid. Okay, last time we have only discussed EVs. Today we are going to discuss how can we connect our EV system to the grid. As you already know, EV system is a DC bank system, right? So if we connect a DC source along with the inverter circuit to connect to our grid, that it can also be considered as we're connecting the EV system to our grid system. All right. So today we are going to discuss the MATLAB simulation of our electrical power system, in which we're going to develop three-phase system with RLC load, and then we are going to connect our synchronous generator or asynchronous motor that are present in our system or in the grid as a load, and then we are going to connect our inverter system to that system. Okay, so I have divided these are the objectives of today's discussion. The first one is to creating a simple three-phase RLC model, in which we are connecting with first of all we are connected with RLC branch. Second, we are connected with RLC load. Then we are going to add our linear transformer, two winding linear transformer, and then we are going to see how the if what's the problem with associated with our non-linear type transformer when there is hysteresis present in our transformer. Okay. The second one is creating a three-phase system with the electrical machine. In this, first we are going to model a synchronous generator first. Then we are going to initialize the generator, connecting. Then we connect it to the grid. Then we measure power of grid. Then adding an induction motor as a load in that. Okay. In the third phase, we are going to create an inverter for three-phase load in which we are converting DC to AC, then adding PWM generator in that to uh, provide pulses or gate pulses to our inverter. Then we add filter circuit in that inverter circuit, analyzing that filter circuit. Analyzing means we are going to see what are the harmonics present in our signals. Then we are going to make rectifiers and how we can model the transmission line losses present in our lines and how we connect these transmission line losses to our current circuit. So this is a simple three-phase RLC model. Okay, and this is the objective in which we are connecting a three-phase source with a three-phase RLC load, and along in all of this we are connecting a three-phase transformer to winding type. Okay, this is the circuit we are going to create. So first of all, we are going to create a simple three-phase RLC model with three-phase RLC branch. Okay, in this we have a three-phase source, then a three-phase RLC branch for the transmission line. Like we, even though we have to connect the three-phase source with the load, in between there are wires that are present. So for that wire, we have to account for our RL resistors, inductance, and capacitance present in those lines. So we are connecting a three-phase series RL branch, and in the output side, we are connecting a capacitor. Okay, this is just a model for three-phase RLC branch. Okay, then in the second, in this, these are the parameters we are going to take in order to develop this circuit. The electrical source parameters are the voltage we have taken is 13,800 volt or 13.8 kilovolt. The source resistance, that means the resistance present in our electrical sources, that is 1 e raised to power minus 3, that is 0.001. Okay, that much ohms resistance present in our source. Similarly, the source inductance is 1 e minus 6, and base voltage is again, these are the parameters that we have to feed in our model. And similarly, the simulation time is zero point 0.1 second. RLC branch parameters are, first is RL branch, what is the resistance and inductance, and then the capacitance branch parameter. Now I'm going to show you this in our MATLAB simulation file. As you can see, this is our same circuit is there. So in this, as you see, we have power GUI and three-phase source, three-phase RL branch, three-phase VI measurement, and three-phase series C branch. I'm using 2016 MATLAB. Okay, so in this, you just have to click in the empty space and write like three-phase source. Okay, the when you write, there is an option coming, the three-phase source that is present in specialized technology fundamental block electrical sources. All right, if you click this, as you will see, a face-to-face VRMS is demanding what's the value it, but leave it as it is. And as you can see, the three-phase source is exactly like that we have used. Okay, if we double click it, then you can see the phase voltage, face-to-face voltage, as we have already, as I've already shown, it should be around 13,800, right? Similarly, the source resistance, that is 1 e minus 3, okay, and 1 e minus 6, and again the base voltage is 13,800. Right, and okay. Similarly, if you want to connect a three-phase RLC branch, just type three-phase RLC branch. Okay, in this, as it is shown, it is saying three-phase parallel RLC branch, three-phase parallel RLC load, then three-phase series RLC branch, and three-phase series RLC load. These are the four options it's giving. So we need a three-phase series RLC branch. So this is the three-phase series RLC branch, third options. And as you can see, when we connect it. So this is a three-phase RLC branch, and we just have to connect it like this. Okay, in the below circuit we have already connected all the system, so you just have to make this whole system and type the values. Okay, when you connect all this system, as you will run it, and in the last slide of our presentation I have already write down all the commands or all the block and their path. Okay, so if you want to connect your system through MATLAB library, okay, so in this system we have a simscape here. In coming on to simscape, we go for power system. Then in power system we go for specialized technologies. In specialized technology we go for fundamental blocks. Okay, if we go in fundamental blocks, there are electrical sources present. Yes, three-phase source is there, right, and DC voltage source is also there. When you go for elements, in elements you can see the three-phase RLC branch, series RLC branch, parallel RLC branch, and also there's load are also present in the same block system. Okay, same library. Similarly, if you want to connect the machines, these are the machines present that we are going to connect in our system. And in the measurement block we have a three-phase VI measurement as there is present in our model, and also the multimeter is also there, voltmeter is voltage measurement device is also there, impedance measurement device is also there, and current measurement device is also there. So we are going to use voltage measurement device and a three-phase VI measurement device along with multimeter in our model. And in power electronics we have universal bridge, and most of the time we are going to use universal bridge. If you are not don't want to use the universal bridge, you can make your own inverter circuit or rectifier circuit using the above present devices like diode, thyristor, GTO, IGBT, idle switch, and detailed thyristor. You can make your own inverter circuit or rectifier circuit by making or joining this component in a particular design. Okay, so this is the whole system that we have made. This is a simple three-phase RLC system. Similarly, if we go for another system, let's come back to this. These are the parameters they have and that I've given to our model. Similarly, if in the second system we are making a three-phase RLC model with three-phase RLC load. In this case, we have connected three-phase source along with three-phase series RLC load. Okay, as I already told you, the three-phase RLC load is also present in the same library where the three-phase RLC branch is present. Okay, and we have connected a three-phase measurement device in this circuit along with multimeter. Here the function of multimeter is very simple. Let's open that model. Let's say this is a model. Okay, in order to calculate the measurement impedance, you can connect a impedance device that is present, that is impedance measurement device. And if you don't want to connect the three-phase VI measurement device, okay, three-phase measurement device we have seen this one. If you don't want to connect this circuit to calculate the voltage value, current value, or impedance value, you can connect a device like this: three-phase RLC branch connected to three-phase C branch along with impedance measurement device. Okay, in this case, if you double click this three-phase series C branch, in the measurement it has shown it is taken branch voltages. Okay, so as we have selected the branch voltage in the measurement, these branch voltages will come in the multimeter current. Okay, the multimeter will check for the number of measurement you have put in these blocks. For example, as seeing the C branch contain the three phase voltages, so the UB1, UB2, and UB3. Okay, these are voltages. And similarly, in this circuit, we have gone for branch current for three-phase series RLC branch, right? In this, we have gone for measurement branch current. So As you can see, there will be three currents, IA, IB, IC, and the capacitance branch, the three-phase series C branch is providing three voltages, VA, VB, VC. Okay, and these multimeters have chosen which measurement value they have to show. Okay, so first multimeter have chosen the voltages, and the second multimeter have chosen the current IB1, IB2, and IB3. Okay, and it is given to the scopes. Most of the time we don't know how to make it the scope with two inputs. Double click it. This is a right. This is a configuration properties. Click it, and in this the number of input ports, make it 2, or as per requirement you can make it 3, 4, and 5. And the moment you make it 2, you want to show your result like this in the matrix form, right? It's a 2 by 1 matrix. So go for the layout, and then in the layout just go for this one, 2 by 1 matrix. And the moment you go for this one, this is how it will represent. If I make it 3 and the layout is like this and apply it, you will see this is divided into 3. Okay, so as per your requirement you can make it 2 or 3 or 4. All right, this was the circuit. If you run this circuit now, in this what we have done is, in the three phase VI measurement we have taken the voltage measurement as phase to phase. Okay, rather than phase to ground. So it is giving us line voltages. And similarly in the three phase RLC load we have taken it as Y grounded configuration parameters, and we have taken branch voltages. Branch voltage matlab VA, VB, VC. So this is giving us phase to ground voltages, the three phase RLC load, and the VI measurement is giving us phase to phase voltages. That means line voltages. So if you run this whole system, go for scope, you will see this system. Okay, the one is going for, the first one is giving the phase voltage and the second one is giving the line voltages. Okay, as you can see, line voltage is root 3 times the phase voltage. If you multiply this whole system with root 3, you will get about 2 into 10 to the power 4. Your maximum peak will go up to that point. All right, so this is our how to make a three phase system with RLC block, RLC load. So in the next, we have to add a two winding linear transformer to the current three phase RLC system. So in this we are going to connect a three phase transformer with Y-Y connection in the whole system with our three phase RLC load. And in this, why we are doing this, because of, if our load is having a voltage rating of different value, then we have to connect our three phase transformer, because the generator is of 13,800 volt, and if our load is 2400 volt, what should we do? Then we have to connect a transformer. So this is the same thing we are going to do in this circuit. So let's see in the open, and this is transformer. So just we have connected. In the previous, we have developed three-phase source with three-phase VI measurement and three-phase RLC. In between three-phase VI measurement and three-phase RLC load, we have connected a three-phase transformer. Okay, you already know where it will be present. Transformer in the element department. Okay, so If we run this program again, on first of all, what we have to do here is double click it. If we want to make a phase shifted type, okay, this is there is no phase shift right now because both the windings are of star type. But if we want to make phase shift, what we will do, make the second winding as delta 1, a delta 11. Okay, it will provide the phase shift 30-degree lag or 30-degree lead, right? So
It will have all this 0, 11, 6 and sare hoge.
no, it only has D1 and D11. In the configuration parameter, there is only D1 and D11. Okay? And the last, as you can see, right? So we have taken Y ground, and in the parameters we will given the values of our windings. So let's say our nominal power is 100 e to power 6 and 60 hertz, and the winding one parameter is 13,800 volt, and the second parameter is 2400 volt. Okay, so it's a 13800 by 2400 uh, transformer. Okay, 13.8 kilovolt to 2400 volt step down transformer is there. So if we run this program, you will see that the V phase load, that is the voltage present at the load side, is about 2000 volt. Maximum value is coming at 2000 volt because some of the voltage will be dropped between those lines when coming up to transformer to our RLC load. So little bit of voltage will be wasted there, and our RLC load will have up to 2000 volt maximum. And this is three phase sorry, source voltage, which is up to, we have already know, 13,800 volt. So it has shown in there. So as we can see how to connect a three phase RLC load which have different voltage parameter to the three phase RLC source using a linear transformer. Similarly, if we don't have linear transformer, okay, we want to add a parameter like saturation or hysteresis loss. So what we have to do is, there is a non-linear circuit is there. This is same as the previous one, just the three-phase transformer with two winding is not linear. As you have seen, there is a line in there which is telling us it's a non-linear transformer. If you double click it, how to make a simple linear transformer into non-linear type, you just have to take that. In the type section there is three single phase transformer. In the next there is a simulate saturation. Okay, if you click it, then the option of simulate hysteresis will also come. Okay, let me show you like this. This is a normal linear transformer. Okay, click it, simulation saturation, then we have simulate hysteresis and specify initial fluxes. We are not specifying initial fluxes, we are specifying only simulate hysteresis. Okay, if you go there and go for power GUI, okay, in the power GUI go for tools. In the tools we have hysteresis design. Okay, in power GUI we have hysteresis design. Can click it to the hysteresis design, and it will provide you a hysteresis loop as per your requirement or the design of your transformer. They have also provided you with the hysteresis loss sheet. Okay, you can adjust any amount of parameter here and then save it. Okay, the moment you save it, in the it will save as hysteresis.mat file as written over here. Okay, and your circuit will look like something like this. And if you run this, a plot will is coming between flux and current because we have connected this circuit also, the below circuit, multimeter with SI to PU, and flux versus current graph will become. And in this scope circuit we can see, because of saturation or because of hysteresis, the waveform is deforming in the RLC load, right? Because In the source, no hysteresis were present. But after it connecting with the lone linear type transformer, hysteresis are present and our waveforms are coming distorted because of hysteresis. So this is the way to connect a three-phase RLC load using non-linear type transformer. So we have done this part up to adding two winding non-linear transformer. In the next case, we are going, and we have also discussed it, enable simulate saturation, simulate hysteresis. By clicking it, then we go for power GUI and hysteresis design. We have covered it, right? Now, in the next stage, we are going to model a synchronous generator. Okay, how to model a synchronous generator in MATLAB simulation. So in this also you have seen the three-phase RLC parallel RLC load is there and three-phase VI measurement is there. We just have to connect what? Synchronous machine PU fundamental. Okay, this machine we have to connect, which is working as a generator. So again, we go for the same system. File open, chapter 3, and we have start circuit. Okay, and the moment we going for this is how it looks like. Okay, synchronous machine PI fundamental is there. If you double click it, okay, and go for parameters, put down your parameters of your synchronous generator. That is, it is working at 13,800 volt at 60 hertz, and the power it is giving is 100 e to power 6, 100 megawatt. Okay, this is we have given, and if we have connected to this whole system. But the thing we want to develop is this: a synchronous generator is, and we want to find out what its rotor speed, what its active output power or reactive output power. We want to check how it is going. So we make another model like this one. Okay, this is the same system in which we have connected a bus selector. Okay, this measurement device, if you double click this bus selector, then this bus selector will show you the amount of signal it is getting from our synchronous generator. It's getting stator current, it is getting DQ component, like I've told you before, that we have to make our three-phase system into two-phase system before. Then we can simulate our machines. So this is the model that is provided by MATLAB itself. But in this also they have developed a DQ model. Okay, and it is also providing a mechanical. In mechanical, we have rotor angle deviation, rotor speed, and similarly we have output active power and output reactive power. So I have selected mechanical rotor speed, output active power, and output reactive power. Based on your requirement, you can choose any parameter from this circuit. Okay, choose it and just select it, and it will come out here. So there are three variables or that reading that we have to find out. So three outputs are coming, and accordingly we have made our scope into input with three. So if you run, we are not going to run it right now because we have to initialize our synchronous generator. Right now we have given power equal to 1 and field voltage equal to 1, right? So next slide, in the our next slide, we are going to initialize our generator. Okay, there is only a single machine system right now. Okay, because we have synchronous machine PU fundamental, right? So in this is a generator system in which we are going to initialize the parameter of synchronous generator. Okay, this synchronous machine. So what we do, we go for continuous power GUI. Okay, we go in tools, and don't go for machine initialization. Okay, because for one electrical system and two electrical system, that means one generator system, two generator system, we go for machine initialization. But if we go for more than two, we have to go for load flow. Okay, in the load flow they will provide the parameters to our generator, to our load or a synchronous machine that we are going to connect in the our upcoming slides. So right now we only have synchronous machine PU, so we are going for machine initialization. There is
Only up to the level of 2 we require this.
we require
More
machine
than 2
initialization,
we have to go for the
load flow studies, because for two system this this machine initialization circuit will provide faster way of getting output. But if we go for more than two, then we go for load flow, because that will provide more faster way of producing result. Okay, we need accurate and fast result, so that's why we go for two system. One system, that is machine initialization for two generating station.
That is for slack bus.
Mhm.
And the load flow means
Swing bus and yeah, right. Okay, so in this we have only synchronous machine PU fundamental. As you select this, then we go for swing bus because there is only one present. So in the swing bus, we have to provide a terminal voltage VRMS and active power. We are providing it. Okay, that much power it's delivering. Okay, and in the three-phase RLC load, we have shown that active power is 40 megawatt and reactive power is 15 megawatt. Okay, in the this system, if we go for tools and machine initialization, we just have to provide 13 and 1800 volt terminal voltage and the active power gas, because our output load is of 40 megawatt. So we are giving 40 megawatt to our active gas. And what we do is compute and apply. The moment you compute and apply, these parameters, the constant parameter changes. First was 1 and 1. Now it's come out to be 0.40052 and 1.26909. As per the load requirement, our input setting of a synchronous generator is also changing. So machine initialization will what it do? It will provide the initial values to a synchronous generator. So this is the thing we are going.
It's already being excited means.
Yes.
It is in the excited state.
In the
Then
excited
it will give
state.
the power out.
Huh. And then you update it. The moment you update it and run it now. So this is the thing that is coming. The rotor speed is decreasing with respect to time, and how the active and reactive power are constant up to the requirement. Because what's the value of our megawatt rating was 40, right? And that is 0.15. So it's giving that much, but it is giving in per unit. So zero point 0.4 and 0.15 it's giving. So we have seen how to initialize our generator system. The next one is if we want to connect our grid, whole system connecting to the grid. So we have a one per unit machine fundamental, and we have a three-phase source also there. Okay, we are taking, if we are connecting a three-phase source, this three-phase source will act as swing bus or slack bus. Okay, and this, and then we can select this synchronous machine PU fundamental as PQ bus or PV bus with respect to our requirement. And in this we have connected a three-phase parallel RLC load along with three-phase resistor load. Okay, the load of the three-phase parallel RLC load of 25 megawatt and three-phase parallel RLC RL load of 40 megawatt active power and 15 megawatt 15 MVR reactive power. So this slack bus and this synchronous generator should provide these values to this circuit. So again, file open grid. So This is the system we have created. We have already made this system, right? Synchronous generator to load. We just have connected another three-phase source. Okay. What we want to make is an infinite bus, right? What is a grid? It's an infinite bus, right? So we are going to make a system where there are one or two and more than two sources, and there are two to three or more than three loads. Okay, if we make this system, that means we are making a grid. Okay, so this is a system we are making a grid in which we have connected a three-phase source. In this system, if we double click it, this is 13800 volt, and this in this we am specifying a short circuit level parameters. Okay, because in the grid system we have short circuit parameters that we have to define for our uh, generating station also. So it has provided that is 100 megawatt is the VA present, and 13800 volt, that is the voltage present in our three-phase source, and X by R ratio is 7. So this is the system we have made. And if we go for the load flow here, this is a swing bus. It will automatically take it as swing bus. Similarly, because we have connected only two, all right. So we again go for continuous tools and machine initialization. Okay. In this we have synchronous machine PU fundamental, and we have taken it as P and Q generator system. Okay, in the generating station we have known it, the one is the swing bus, then is the PV bus, and then is the PQ bus. So we are already defining the P and Q value for this synchronous machine. Okay, so we have that 65 megawatt is the power that is going to deliver maximum to maximum, and the reactive power is going to deliver is 15 megawatt MVR, sorry, 15 MVR. So if you compute and apply, okay, it will give its value to this these constants. Okay, and if you run it again, because we are running for the 10 seconds, it will take some time. If we go for 0.1 second, it will take very less time. Then according to this, we have to change our configuration parameters. If we model configuration parameters is there, and just change the solver here. Okay, variable step, it is already have taken the ODI to TB stiff. It's this solver is already providing the best result for this complex system. Okay, and it is already faster than the other solvers. So this is the our generator whose speed is, we are saying the rotor speed is moving, varying variable speed we are getting, and similarly the output active power and reactive power is delivering is around 0.65 and 0.15, okay, per unit. And similarly, this is the voltage and current we are getting from our synchronous generator. We can also find the amount of power that is delivered by our three-phase source, and in this we have connected a power three-phase instantaneous power block, and then connected to the grid power. So if we double click it, as you can see, our grid power, the three-phase source is providing around 0 to 100 watt, and the reactive power it's delivering is about zero, because all the power that is that we need to give to our loads are provided by synchronous system or synchronous machine system. So it's providing less power and reactive power to our loads. So if we go for now a synchronous machine system, okay. So we have already covered that electrical power source. We have to enable specify the short circuit level parameter in which we have to provide face-to-face base voltage, base VA and X. Similarly, in the power GUI block, we are going for machine initialization and we are going for machine list. In the machine list, we are checking the bus type should be a PQ generator type. And then we have to specify active power and reactive power in that circuit. So in this, Next thing is adding an induction motor. As you've seen in this, we are adding an asynchronous type machine PU system, right? We are making a three-phase RLC load and we are connecting it with the three-phase transformer. This is the whole system in which we are connecting a connecting a synchronous machine along with the three-phase load. So in this we are going to specify we are using the transformer. So the transformer will be of 13.8 to 2400 kilowatt, 2400 volt. Okay, that type of transformer we will be using. The load will be of also 2400 volt. Okay, so again going to this system, motor. So this is the system we are connecting. Okay, in this we have connected a three-phase transformer with two winding and a asynchronous machine PU. Okay, because now we have more than two system, two generating units are there, one asynchronous machine are there. So in order to initialize these three, all right, we going for load flow rather than machine initialization. So again, in this circuit, if you check this, the parallel R branch, okay, is of 25 megawatt type, but it's a voltage of 2400 volt because we have connected a transformer parameters 13.8 kilowatt to 2400 volt type. So similarly, these parameters are also 2400 volt and 25 megawatt type. So as you will see, this machine required 25 megawatt. This RL load, this R load provide 25 megawatt. This RLC load provide needs 40 megawatt and 15 MVR reactive power. Okay, so all these values should be provided by these two parameters. Okay, so if you go for continuous PVR joke, so first of all, what we have to do is make this system in the load flow, make it PQ bus. All right, synchronous machine PU system, because this three-phase source will act as a swing bus always. Okay, and then we make this synchronous machine PU fundamental. In the load flow, we will provide generator type is PQ. Then we will provide the active power generation is 75 megawatt, and reactive power it can provide up to infinity. Okay, that we have given. In the similarly, in this case, in the load flow, we have given the mechanical power is 25 megawatt that is required, and in this load flow is swing bus. So if we go for continuous power GUI and go in tools and load flow, okay. So here, this is the whole system. If we compute it, okay, we have to click on the compute, and you will see the asynchronous machine require 25 megawatt. Okay, RLC load require 25 megawatt. SM, that synchronous machine, is providing 75 megawatt and 25 MVR reactive power. RLC load is of 40 megawatt and 15 MVR, and this is our voltage source. Okay, and how much power it's delivering, because P and Q is not defined for swing bus, right? So this load flow is actually calculating the amount of power that is delivered by the swing bus, the SM, and how much power it is giving to the loads. So as you can see, the amount of power ASM is getting is 26 megawatt and 19.37 MVAR. Okay. Similarly, our RLC load 40 and 40 megawatt and 15 MVAR is required, and our synchronous machine is providing 75 megawatt power, active power, and 25 MVR reactive power. It's showing it's there. Okay. Similarly, the swing bus is how much providing? Swing bus is providing 18 megawatt. Okay. Right now, it's not given in there. where we have put the parameters. The swing bus is of how much megawatt or how much reactive power it is giving. We didn't know, right? So and by computing it, we have actually shown that the swing bus is providing 18 megawatt active power and 11.87 reactive power to the whole system. Okay, if you add up, it will come out to be the amount of reactive power that is needed by asynchronous motion motor as well as by RLC load Z. Okay, then you apply it to the model. After computing, apply it to the model and then run the whole system again. So this is the motor parameters. Only speed is there. Okay, so it's around 0.97655. Okay, this and this is the output active power and reactive power provided by the synchronous machine and its speed, how it's varying with respect to load, and similarly the amount of power that is delivered by our swing bus, this much. As you have already know, 19 megawatt is provided by active power is given by our swing bus. So it's coming around 19, right? 19 megawatt is coming around. And similarly, how much reactive power? 11 reactive power, 11 MVR, mega MVR. So it's coming around 11.8 MVR, right? So this is showing the exact result that is coming in our circuit. So load flow analysis, by doing the load flow analysis, the whole circuit will initialize in a faster way. Okay. So
If we have a single machine, we can go directly to the load flow analysis or
go for
we must.
machine initialization. You can go for load flow, but अब वही है ना कि कहते थे कि हथौड़े से काम चल रहा है और आप क्रेन उठा के ले आए, वो यही बात हमारी होती है ना ज्यादातर, तो वही सिस्टम है यहाँ पे भी. So the next thing is we're going to discuss is converting DC to AC inverter with PWM generator. So in this we have used a universal bridge. A universal bridge is a simple bridge circuit, three-phase bridge circuit, which are utilizing 6 switches. So we have given a PWM generator with 6 pulses to this our universal bridge circuit, and this we have taken a DC voltage source. Rather than taking a DC voltage source, you can also take PV cell system with boost converter, and also you can use EV system or wind generation system or fuel system. Okay, fuel cells you can use. You can apply anything here. Okay, I'm not connecting it that because they are all what are they doing? They're giving a DC voltage. So in the hybrid system where you're connecting your PV system, fuel cell, and wind energy system at the DC link, they are giving the constant DC output. Okay, so that system is different. Okay, and this system is different. Okay, you have to just connect it. Okay, so in this we have taken the series RLC load and universal bridge and three-phase VI measurement device. Okay, and in this we are taking a DC voltage source of 900 volt. The universal bridge is of IGBT diode type, and the R load is of 600 voltage, and active power required by it is 1 megawatt. Similarly, the PWM generator two level is of carrier frequency 3000 type. You can change your carrier frequency up to your design. Okay, and in this you have to let me show you something first. This is the system. If you write PWM generator here, two level type. Okay, this is how it actually looks like. बिकॉज इट्स रिक्वायर्ड एन इनपुट, एक रेफरेंस वैल्यू उसके पास आनी चाहिए जिसके ऊपर कंपेयर करके करेगा. But if you don't want to give the reference value, so what you have to do, double click it. Okay, and this internal generation of reference signal is there. Just click it. Okay, and provide the modulation index 0.75 or according to your design कि मेरा modulation index इतना होगा और इतनी ये wave generate करेगा. ठीक है, जब आप ये करेंगे तो ये सर्किट कुछ इस तरह से लगेगा फिर. ठीक है, now it providing a PWM signal which is required by our IGBT system. So this is a simple circuit. Okay, universal bridge, as you know, just type universal bridge. Okay, this is a universal bridge. It's different from this. Okay, the same universal bridge can be used for rectifier purposes also. Okay, but we are doing what we are doing right now. We are making an inverter system. So this system has to change a little bit. Just press Control I. Click it and Control I. This is for इन्वर्टर, राइट. डीसी सोर्स को लेना है, थ्री फेज को सिस्टम बनाना है. ओके, अगर आपको इसको रेक्टिफायर लेना है तो आप क्या करोगे, जस्ट मेक इट दिस वन. थ्री फेज सप्लाई इट विल टेक ABC and it will provide DC voltage. Output will be there. So you can make the same universal base system into an inverter system and into a rectifier system. Okay, if you double click it, then there is a circuit that power electronic device. Okay, here it is using thyristor that uses as IGBT diodes, so it will somehow look like this same one. And if you want to make a rectifier, just use diodes. It will, right, the same system can be used for as a rectifier and also inverter. Easy, right?
Yes.
So if you run it, this is how it actually looks like. Okay, you can see the blue, orange and yellow, right? If you see it, it's not a good waveform, but it's still giving a sinusoidal type, little bit sinusoidal type, right? Very little sinusoidal type, because it's connect and it's having way too much harmonics. If you want to check how many harmonics is present in this, so first of all, go for scope, configuration properties, logging, log data to workspace. If you go for load data to workspace, then it ask you variable name, and the save format should be in structure with time. Okay, apply it and okay it. So then go for power GUI, because inverter circuit requires switching. Okay, for for this purpose only we go for discrete type solver in power GUI. As you can see in the simulation type solver, simulation type, we first were going for continuous type, right? In all the previous example we are going for continuous type, but the moment we came for switching devices or our inverter circuit, we are going for discrete type because it's providing good results. Okay, in the toolbox, go for load flow, sorry, go for FFT analysis in this, because you want to check how many harmonics are present in this signal, right? So go for this circuit. Okay, it's not showing. So what is showing, the scope data was the parameter that we have given to our workspace in the scope system, and the input is variable V, and that in input we have three different waveforms, VA, VB, VC, right? So the signal is 1, 2, 3. So we are calculating for 1. If you want to calculate your harmonics present in the signal, don't go for one cycle. Okay, go for 5 or more than 5 cycles. Okay, we have taken 5, and the maximum frequency preference should be more than, we have taken 10,000 because our signal carrier frequency is 3,000. So we are going to calculate what the harmonics present at 3,000, 6,000, 9,000. Okay, so we are going for 10,000, and then we are going for display. So as you can see in this circuit, inverter circuit, the amount of THD present is 98%. So it's not giving a good waveform. So if we want to make a better inverter system, either go for multi-line inverter system, or you can go for filter circuits. Okay, so next we are going to check the filter circuit. This one. So in this we have connected an LC filter. The first configuration was that what, DC voltage source, IGBT, then VI measurement, and three-phase series RLC. Now we have connected an LC filter at the output of inverter. What is there in this system? There is an L branch and a C branch, three-phase L branch and three-phase C branch, which is making our LC filter. Okay, in this system, after connecting this, I have made a subsystem. Okay, a subsystem is what, if you select all this system, okay, and then right click it. Here is create subsystem from selection. Okay, the moment you click this, it will make a circuit like this. Okay, this is the circuit present in our system, right? And this is the system, but can I've chosen that system like this, and then said create subsystem, and this is how it will look like. Then change the name according to where it's a LC filter or RC filter. Check it. Okay, and then run this. In this, we also check that the scope should have the logging, and it's have log data to workspace should be click over here, and the variable name should be given scope data, and the save format structure with time should be given. Okay, we have to check this thing, and then we run this program, and again go for F15 analysis. So how many harmonics are present in this system? So the system is actually looking like this. Okay, the waveform is somewhat sinusoidal, right? By applying the LC filter, our waveform has improved. So again, in this system, voltage is there, signal is giving 1, and we have to give number of cycles 5, maximum frequency should be 10,000, and then display. So as you can see, the harmonics present in the signal is 7.60%. In the previous case, it was 98%, right? By using the LC filter, we have reduced it to 7.6%. Okay, but what's the main advantage in MATLAB? We can take any value of L and C, which is not the practical case, right? So we have to go for multi-line inverter circuit and then apply the filter circuit. Okay, because after applying the multi-line inverter circuit, the number of harmonics present in the output of inverter will be around 12%, 11% if we go for 11 level type. At that point of time, the amount of harmonics present is only of 11 or 13 type, highest frequency that is present in that signal. So the filter circuit requirement for L and C will be reduced. Okay, those equipment we can get and make an easy filter, very cheap filter we can get. So this is how we make this whole system, in which we have uses a filter circuit, and how can we calculate the number of harmonics present in that signal. Next thing is inverter with LC filters is also there. We have log data to workspace. All the commands that you need I have provided in the presentation. Okay, the steps you have to take. In this, we are going to create a rectifier system. Now we have make, what did we have make? We have made LGBT inverters along with the RLC load. Now we are connecting this system with the diode rectifier and providing to our load system. Okay. So again, going for this circuit, open rectifier. this is the system we have created. Just I have shown you, in order to make a diode rectifier that like this type, you use universal bridge and make use of diodes. Like double click it. This is a universal bridge, okay? And in this power electron device should be diode type. Last time we have used an IGBT type, right? IGBT diodes. In this we are using diode type because in the diode you don't require gate pulses, so it's a simple rectifier system. So and then you can provide the inductor and the load. This is similar circuit like this system. Just use the parallel RLC branch or parallel or series RLC branch in order to connect this whole system. Okay, if you run this program again, you will see this LC, this inductor and this load will be providing a filter. Means it will reducing what the ripples present in our signals, because as you already know, in the all the rectifier present in our system, they will give you a ripple output, not pure DC, right? So we are connecting a filter circuit here with inductor and RC, and it will give us almost constant DC. Okay, it will providing us almost constant because in this you can also see there are ripples present, but the amount is very less. Okay, so this is how you will make a diode rectifier circuit. Now in this, the last thing that we have to do is in this is three-phase PI section line. In the grid system, we have transmission lines, right? So in the transmission lines, we have to give what we have to give is what's the R value, what's the inductance value, okay? How much length it is, what's the power required by that line. So this three-phase PI section line is provided between inverter circuit and rectifier circuit. That means our inverter is present at somewhat 5 kilometer or 10 kilometer distance. So we are providing what a three-phase PI section line in between this circuit. This this thing is only given because the distance between the rectifier circuit and inverter circuit is very long. That means 5 kilometer, 10 kilometers. Like you are sitting here and you want to operate a circuit in sector 29. Okay, at that point of time you need lines, transmission lines or distribution line. So this three-phase PI section line will be providing the parameters for those lines. Okay. So again, we open circuit. This is the circuit in which we are providing three-phase pi section. In the pi section, we are providing the 60 Hertz frequency, and we are providing inductance value, resistance value, and capacitance value present in this pi section line. And we are given the line length is 5 kilometer. According to your requirement, if the line length is 10 kilometer, these values will also change, right? So if you want to design any circuit or grid system, just go for what are the parameters that is required by that system and just put it here. And this is what a transmission line look like, a grid system, how it will look like. Okay, so we are going to stop here. We are going to stop here. These are the parameters that you have to give by your side, and then these are the blocks that we have used in the circuits, all these circuits, and along with their path in the simulation library. Okay, just check it here and you will get the blocks. Otherwise, if you don't have 2016, MATLAB 2016. Because in the MATLAB 2016, you just have to type in the empty space, make a new model, type it, and it will come. The block will come. Okay. So these are the all the elements that is present in the system. The second one is this, and the third one is this. Any question, please? Because I really want to tell you how we work in the MATLAB simulation. Uh, I think did any teacher told you how to use this circuit MATLAB like this?
During this course, it is not.
Because this is the only yes, in the Saturday program they have shown that MATLAB simulation will be there. So I wanted to show you that how we work in the MATLAB simulation, how we connect this electrical system and make inverter circuit or rectifier circuit, and how to connect it with the grid system. So in this we have already discussed how to make a three-phase system, then how to make a three-phase system with synchronous generator source, or how to connect asynchronous motors loads or RLC load or R load. Okay, and then we have made inverter circuit and rectifier circuit and connected with our transmission line pi section, right? So this is the whole system. And if you want to make an electrical system where you want to connect a DC system like PV, wind energy system, fuel cell, and electric vehicles to the grid, what you need requirement is you need a chopper circuit. Ma'am already told you how to make a chopper circuit, then inverter circuit. In between, there is a transmission line parameters you have to provide. Okay, so in this system, I have given you up to inverter circuit. Okay, after that, you need a DC chopper circuit and a DC source like PV and that. So if you go to your home or colleges, just try to develop a circuit in which you are needed a battery circuit or electric vehicles, or you are giving a standalone PV system and connecting it to the whole system. Because I've already shown you up to the inverter parts. So at that point, rather than using the DC voltage source, you can use that system with boost inverter, boost chopper circuit, and PV cells, wind energy system, and fuel cell. So, so that will be your work in the future. So this is the system, and thank you very much. Really glad that I've told you how to use the MATLAB circuit in the electric power system.
Thank you. It's really covering all the aspects.
Okay. Many questions from them. They are the load center. What's nodal center? I'm okay.
Okay.
Yes. Sir. I want to ask the question if they want to ask.
Yeah. Nodal centers, if you have any questions, you can ask.
Tamil Nadu.
Yeah,
Ma'am, we understand the three-phase, ma'am, three-phase inverter. We learned the simple techniques, key techniques, how to go for that. It's easy, ma'am. We understand. We don't have any doubt. Thank you, ma'am.
You don't have any doubts.
Okay, okay.
Are you satisfied with the program?
Was the lecture good? Because program हम last में पूछेंगे 11:50. Was good?
Compared to last time, this is helpful for me, sir. My area is PV panel, so it's
Yes.
helpful for me. But converter side, DC to DC converter I used. But here
Yes, sir.
inverter, first session I got, I impressed. First 1 day or 1.5 day I impressed, sir. Because
Okay.
that is a ma'am discussed with DC to DC.
Yeah,
Yes,
DC to
yes,
DC
yes.
converters. Yeah.
Now it is inverter, but I can learn some key points. How to use universal bridge, how we can invert it, inverter, what is that? Inverter, rectifier, a single universal bridge, how we can use it. That we
Yeah.
learnt. That's helpful for me.
So any stage, if you see, say if you go only to say PV to DC converter, you'll get stuck there, because nowadays so much research is going on. So you have to go till the grid. So for that, you like when you do research, you learn. Like when you're doing your work, you'll understand whatever we are trying to do. Already papers will be existing. So we
Ma'am,
have to, yeah.
ma'am, if I'm going to convert my converter to DC to DC output to AC application means I'm going to investigate inverter also, ma'am. That is also a
Yeah,
big ocean. I'm afraid
yeah.
that in that area.
Yeah, no, it is not. You need not get afraid. Once you start working, it'll be very comfortable. The thing is, that is, you have to get some idea. So this course mainly it'll give you many ideas, and now you have to go and explore it. So there is
Ma'am,
the
we want
challenge.
a separate course, ma'am. Pardon, ma'am. We want a separate course for only DC to DC, ma'am.
Okay, yeah, that'll also be, because next
Ma'am, you
time,
covered 3 days inverter, ma'am.
yeah, that is there. That is there. Because now this one main our aim was with the grid. So when you go to the grid, you require inverters also. DC to DC converter, I just felt like I can go to other models. Only DC buck converter I discussed in detail. I didn't do it boost and buck boost also. But we
Ma'am,
had all the materials for DC to DC converter, like the boost and buck boost. But since I didn't cover, I can tell you, go to Netmo and book, and you can just have full modeling there. And how you did for buck converter, same modeling you have to do for the other two, and you have to just implement it in MATLAB. And you need not worry, all these things, buck converter, buck boost converter, boost converter, all the modeling are already available in MATLAB file exchange. Okay, so again, go and reinventing a wheel is not required there. You have the models available. Now you have to do is how to implement MPPT. So what are the different MPPT techniques available? When you go for boost or buck boost, it is non-linear. So what type of things you can implement that? Those things has to be discussed.
in future, we expecting some course like that, ma'am. Only
Sure,
DC to
sure.
DC.
Yeah, yeah. No, we like a future, like already the next hour plan is also planned. We have power electronics course. In that power electronics course, we will give more importance to all the converters. It is not only the inverter or anything, all the converters. We will have separate two days for DC to DC converter, and then 2 days for
AC
like
to DC. And
AC
then
to DC,
AC
everything.
to
Yeah.
AC.
In the power electronics course, we have one. The next open we have a power electronics course and its application. In that, let us try that, as you said, from the modeling, from the mathematical equation, how to model it in MATLAB, and then how to implement it in applications. We will just cover that. That was a good suggestion. We will surely do that.
Thank you, ma'am. Thank you, ma'am.
So now we will just break for tea for 15 minutes. It's 11:15 now. Sharp at 11:30 we will be back. Okay, so the participants, those who don't have doubt can go. Those who want to ask some doubt, you can ask. Others can just go. And even in the nodal centers, you can have your breakfast till 11:30. Nodal centers, if you have any doubts, you can just ask, sir. Here also, do you have any doubts or something you have cleared it? Okay.
Yes, sir. Hello.
Yes.
Question. Hello. I'm audible.
Yes, we can hear you.
सर पावर क्या है हम सिमुलेटिंग मोटर में हम यूज करते हैं
जी
Once again, repeat it.
सर पावर क्या है जो हम सिमुलेटिंग मोटर में यूज करते हैं उसका सिग्निफिकेंस क्या होना चाहिए क्या होगा
किसी का सिग्निफिकेंस पावर क्या था वो एक बीच में टेबल भी है ना once again please repeat it
पावर क्या है मैम पावर है यस मैम वी यूजिंग इन सिमुलेटिंग मोटर
which motor
हेलो
you are using which motor
simulating the motor
simulating the model or motor
simulation model
yes yes
yes sir signification जानना सर अगर कोई बोल देता है मैं बोल significance जानना था सर
significance जानना है see the question is not clear you can come near the mic and tell because we can hear our echo Can anyone come and slowly tell the question because it's not clear? Full disturbance.
Ma'am, what is the significance of power guide?
Okay, what is the significance of power diode you're asking in simulation? Power diode. Power diodes are important methods because when the switch is switched off, also there will be some extra charges in that. So it is just for bypassing the extra electrons present there. Okay. That is a reason I think whenever what is this question is whenever we put a switch there, you put a bypass like parallelly a diode.
Yes,
That is for fully like commutation purpose. It will be helpful, or like say when the current is flowing through the diode, sorry, through the switch, it is on. But when the switch get turned off, okay, the extra charges has to be flushed out. So this gets bypassed through these diodes. So for perfect commutation also you can say they are bypass diodes. आपने अपने मॉडल में किया था bypass diodes.
in the universal bridge you have used
Okay,
diodes.
universal.
उसमें rectifier बनाना था तो उसमें diode
डायोड्स होता है मेनली वो स्विच के पैरेलल में एवरी टाइम डालते हैं ना बिकॉज़ दैट विल बाईपास
जब IGBT ना तो उसमें diode लगते हैं ना हमारे.
हाँ हाँ वो तो लगता है okay the centers if you don't have any doubts you can have your small short break 11:30 we will be back okay our next expert is also there so he will do the setup okay आपको setup अभी करना है कर लो So we are on the last session of this STC, and we have with us Mr. Alok Deep. So he was our student here. He is an alumni of NITR, and he has started his own innovative skill laboratory here at our institute. Apart from that, he's having his own company. It's a startup like of our institute, and he's working with all these power electronics devices and making kits, power electronic based kits, and they conduct courses for different institutes. They will go to different institutes and conduct courses based on Arduino. So if you are interested, you can even call at your institute. They will come and give training for your students. It may be 1 week, or a workshop can be organized where they will just give you insight on all the Arduinos from the basic installation. They will install it. They will give you the software. They have the kit also available with them. You can purchase it from them. And they go for many robotic competitions. They conduct competitions at our institute, and they just train the students for these Arduinos and many other digital embedded systems. So now they have a very small project here, because like 2 or 3 weeks back, we had a program for solar. It was fully based on solar. That was, they had real big models also available. They had solar panels and DC to converters, and they did a thing. So here all these things cannot be brought. So I was just telling him that you can just make a small prototype of it, so that people will come to know about the insight of what is really going inside that. So based on that, like our students here, with his help, they have done solar tracking system, that is automatic tracking system, as I already told you. This is four axis tracking, so it can track on all the 4 axes. So why that is 4 axis is required, that also he may give you insight. Instead of 2, why we go for 4? Because based on the sun's, like throughout the year, if you see, the sun's position is not only this. So that might be, he will give you all those insights, and he will just tell you about the different hardwares involved. And I think that is like, if intelligent tracking of this system is what he's going to give you. So, and as I like, all the nodal centers are also available at sharp 11:45. This lecture will get over, and we will just go into a valediction session. Okay, so I hand over the session to Alok Deep.
Thank you, ma'am. A very good morning to all. Myself, Alok Deep, Director R&D at Innovative Skill. Innovative Skill is a company. We have a collaboration with the NITRRR, Central Government, MHRD, to improve the skill to build fill the gaps between the practical and theoretical knowledge, because the student have only theoretical knowledge in this time. So we are bridging the gap, so giving them projects, hands-on experiment, hands-on training. This is all over. And what we do, these are the main contents. What we do: workshop, training, renewable energy. We have worked in the renewable energy. We have organized a workshop on solar recently. And entrepreneurship development. Entrepreneurship is also a very important area, because when we give them, when they support them, they will also can start our company. So entrepreneurship development is our also a work area, major area, renewable energy, and workshop on training. The main difference from the other training providers and the innovative skill is that we are providing the workshop totally hands-on experiment, totally hands-on, because they are students are knowledgeable, they are knowledgeable person, they have the knowledge, they have good marks also, but they are lacking in the practical things. So it is the need of the society presently, then how we can increase the quality practicals hands-on experience in the student, so that they can get a placement, they can get our startup, they can get consultant, they can give the consultancy to the other companies, and many of all, because the true knowledge is the practical knowledge. How we can you can generate the money, how can you generate, how you can give the benefit to the industries, like we are consulting the other country, other industries for consultancy problem. We have some problems from the Delhi based companies and other also. to improve the quality in the industry, to make the profit in the industry. This is the main purpose of the knowledge. Now we are entering in the manufacturing of the green vehicle R&D projects from industries and research organizations also. Okay. These are the contents of my presentation, and this is hands-on also. I will give you the Arduino microcontroller, that you can check how it is will program, how what pin configurations, the components in the Arduino. Okay. uh, at first we'll start from the solar tracking system. What are the components required in the solar tracking system? Then we go to the different in the deep of the all the components, like microcontroller and driver IC. What is the need of the driver IC? Why we use the Arduino microcontroller? What type of the components are used in the Arduino controllers? Okay. And then how to program the Arduino, because it is a 1.5 an hour lecture, so we can get the information. And if you want this in the details, then we can organize a workshop in your college, as we have trained nearly 1,000 students till now, from the polytechnic, from engineering college, teachers, and different projects from the industries. Solar orientation, sensors, I will give you some information about the sensors, why, where the sensors can be used, which type of sensor are used in the solar tracking system, this type of system, and why this sensor is used, what is the specifications of the sensor, how it will work. Okay. Then we will go to the DC motors, which is a component of the solar tracking system. DC motor, motor driver IC, Bluetooth interface, and tracking real-time data of the solar tracker. Actually, the client needs is that they want the real-time data. How much our solar panel is generated presently, real-time data, which voltage is generated. We have developed a app using MIT app developer, by which we can get the data from the solar panel, which how much voltage is generating it presently, current time. You can track this voltage on your mobile phone, Android, and you can also program the Arduino with your Android. Okay. And solar tracking system, we have the video of the solar tracking system. I will show you the video. I will show you on the hardware also working here. Okay. And we have the YouTube learning channel, e-learning channel also, in which nearly 10 to 12 videos are there, and you can learn from we have the videos of STCs here, and where you can learn the how to program Arduino, how will robotics arm will made, and components of the robotic arm, and projects. Okay. Introduction, why the solar tracking, why we made the solar tracking system, what is the advantage of the solar tracking system. These are the points. The most energy is absorbed when the surface face is perpendicular to the sun. When the solar panel is perpendicular to the sun, the maximum energy is absorbed. And in normal condition, there's only one time, only one point is there at which the sun is perpendicular to the solar panel. So if there is no tracking is there, then efficiency is decreased. Okay. So we want it to face throughout the day 90 at the 90 degree of the solar panel. It tracks where the sun is moved. Okay. Because I will also show in my PPT that the sun's track is changed in the summer and winter. The orientation is different in the summer and in different in the winter. So we have to track it. It is important to gain the maximum benefit, maximum energy from the sun. Otherwise we will lose this energy, and it is not a very efficient system if we are not using this. Okay. Then stationary mounted PV panel are only perpendicular to the sun once a day. केवल दिन में एक बार ही होता है वो perpendicular. Improved performance from the each panel means fewer panels are needed. अगर हम हर panels की performance को increase करते हैं, if you increase the performance of the panel, then less of the solar panel are needed. Okay, it is the advantage. Less solar panel means less cost of the system. Okay. At first, I want to show you the solar orientation. Please see in the slide. Solar orientation, it is the summer. In the summer, you can see the tracking is in the summer is this. It is, suppose this is your house, okay, and in the summer is sun is orientation is upward from your house. Okay, you can see Okay. If any point you are not understanding, you can ask the question. I want it to bidirectional conversation. You can also ask.
You can
Yeah.
calculate the declination in a limited angle.
Actually, these are the values in the particular degree. I don't know. It is not my deep area, but it is somehow I know from the internet, from some books. I have know this is the orientation. We will get the information in the particular degree you want. You can get the information.
There are two angles corresponding to the orientation. One
Yes.
is azimuthal angle,
Yeah.
one is a declination.
Yeah, azimuth angle is there also. We can calculate in the azimuth angle or degree. It depends on the purpose how we are using these angles. Okay, I am only saying that for solar tracking, why the solar tracking is needed? Because the track is different for the summer and winter. The purpose is only that.
The azimuthal angle and the declination angle keeps on changing.
Yeah.
So this takes into account. So
Yeah,
that's
yeah,
why I was asking you why without the consideration of these angles you can't even think of creating a solar tracking system.
Okay, actually solar tracking system, if angle is changes or the position of the sun is changes, it will track automatically. There is no any need to feed the value of the angles in the solar tracker. It will rotate according to the condition of the sun, where the maximum it is perpendicular to the solar tracker.
Exactly. That angle should be matching up. There should be some degrees of rotation. No?
Actually, it is a feedback system. It is not the angles we are feeding it in solar tracker. It is a feedback system where
Based on the perpendicular
yeah
axis.
where he founds that angle, he will automatically rotate to that. You can see in the demonstration. I will show you. Okay.
Sun seeker axis and solar axis. So that should be parallel to each other.
Yeah. Yeah.
So three-dimensional movement is there, or
Through three-dimensional movement is there, because there is a 2 degree of freedom x and y. Then it will track any direction. Okay, you can understand when I will demonstrate this solar tracker. Okay. Okay. This is a block diagram of solar tracker. In this servo motor, you can use the servo motor. Here I use the DC motor. Servo motor you can use for the movement. Solar panel for generating the voltage. Okay, so two servo motors are there for x-axis and y-axis. For x-axis is one motor is for x-axis, one motor for the y-axis. Okay, LDRs for light dependent resistors to check the condition where it get the maximum output, maximum light. Okay, Arduino for controller controlling or checking, for algorithm where you want to move, what is the condition, what are the values are coming, read the values. Okay, power supply for the system for Arduino, and for motors. Okay, battery charge controller, you can use charge controller for saving the store the voltages in the battery. You can use the charge controller, then it will give the battery. But we are focusing on the this movement part and controlling part. Okay, you can save the voltage, but I want to show you that we can control the solar panel according to the light conditions. This is the main. Is a component requires LDR sensors. I will show you on the hardware part also. When I will come on the hardware part, I will show you the LDR sensors. Okay, one by one. Then servo motors. Yeah, here in this tracker you can see the DC motor, pulley and gear system for movement of the solar panel. Here I have directly attached on the axle of the motor. No need of the pulley and gear system. Pick microcontroller is there. You can use any microcontroller, Arduino microcontroller, 8051 microcontroller, pick microcontroller, as you are familiar with the controller, as you feel comfortable. Solar charge controller for converting the panel voltage to store in the battery. Charge controller is used. Okay, this is all about the components required. Then we will go on one by one in the detail. This is the main components. Now microcontrollers. Microcontrollers, why we use microcontroller? Anyone can tell controllers why we use? Anyone can say why we use microcontroller? Microcontroller, we yeah.
You can call it as a soft computing as well as automatic controls.
Yeah.
Use microcontrollers.
Yeah.
It is a technique of soft computing, you can say.
So computing actually in a simple way we can say that it is a brain of the system. Yeah. When you get the values of from the LDRs, the light values, then the controller will say where the maximum light is there. It compares the two voltages from there four LDRs are there. It compares the from other LDRs to the other LDRs. Then it will give the output to the motors. So it is the brain of the system. Microcontroller is used here. The Arduino. Here I used the Arduino microcontroller. It is the platform, Arduino platform. It is easy, it is convenient. You can make the project very easily because on other microcontroller you have to program, you have to purchase a burner also. You have to learn time needed to learn all the languages, all the syntax. But in the Arduino you have predefined libraries for the short purpose, for the short project and college level. You can use it. It is very easy. So these are you can share one Arduino microcontroller. You can see I will say you can please give one by one microcontroller Arduino. Okay, I will explain in this you can see the pin these pins controllers. Okay, now you can see in your board at first one by one as I will say. You can see in the board and then in the PPT. Okay, at first the USB. Please see the USB. Okay, this is for power and program also. This is used. This will connect with the your laptop, your computer. Okay, and now you can also program it with the Android phone. This apps Arduino Droid is there, by which you can program it using Android phone. Don't no need of the laptop or computer is there if you want to program it. Okay, so this one is used for program. Okay, programming and power both for the both purpose. This one is the external power. Okay, it is used for the power supply, power only power, not for programming. At one time you program the Arduino in this controller, the program is saved. Otherwise, and when you program it another program, then it is overwrite on the previous one. Previous one is erased and new one is overwrite on that program until this program is contains in the controller at इसमें जब तक आप नेक्स्ट प्रोग्राम इसमें नहीं डालते तब तक पहले वाला प्रोग्राम इसमें सेव ही रहेगा. इसमें आपको कोई चेंज करने की जरूरत नहीं है कि अब कितने टाइम तक भी आप यूज कर सकते हो उसको. ठीक है, अब नेक्स्ट इसमें देखते हैं ये 3.3 वोल्ट पिन. प्लीज सी 3.3 वोल्ट पिन. गेट एनीवन हैव प्रॉब्लम on getting 3.3 volt pin? 3.3 volt pin is there. Yeah, get 3.3 volt pin is used to give a 3.3 volt power to the other circuit, not itself, to the other circuit. Okay, if you want a sensor which require 3.3 volt, then you can give power from this pin. Okay, clear. Now 5 volt pin. Okay, 5 volt, you find the 5 volt pin. This is a 5 volt pin. The same reason is there. For other circuit, it will give the power to the other circuit. 5 volt pin. Okay, please do not give the power from this pin in the Arduino. If you give the power from this pin, Arduino will damage. Okay, you can give the power to the other pin. I will say now ground pins. You get the ground pins. Okay, these are the ground pins. Two ground pins are there and one ground pin is there. You can see. Fine. From beside of the 13 pin.
Yes, sir.
Yeah. Okay, ground pin is there. Now V in. You get the V in. V in is also a source by which we can give the power to the Arduino. Maximum power you have to give is 12 volt. Okay, if you increase the voltage, give the more voltage, then the Arduino board will damage. So it is the recommended that you will give 12 volt voltage in the V in pin or external power jack, but not more than 12 volt. Okay, then so you can get the three way to power the Arduino: the USB, the external power, and V in. Get it? Okay, any problem, any doubt? You can ask now. From A0 to A1, A2, A3, A4, A5. These 6 pins you have found. These are the analog pins. The output from the LDR sensor is given to the analog pins. Okay, it will take the signals from the sensors. Okay, and you can take the 6 signals simultaneously, analog, from analog pins like LDR, IR sensors, potentiometers. These sensors are the analog sensors. You can take the values, take the sensors values from the analog, from A0 to A5. These are the analog input, only analog input, not analog output. Please understand, analog input is there. You can only take the input data from the sensors. Okay. Next, 0, 1, 2, 3, 4 to 13. Get it? These are the digital pins. Yeah, these are the bidirectional. You can use as an input or output. It depends on you. You want, in which the pin number 0 and pin number 1 are TX and RX. Okay, these are used for communication, like Bluetooth module communication. If you want to take the data from the Bluetooth, then RX and TX pins are used here. And there are also used for PWM pins. Okay, 3, 5, 6, 9, 10, 11. You can check on the board, then there is some mark, negative like mark on these pins. Get it? 3, 5, 6, 9, 11. There are negative type marks are there. These are the PWM signs. Means you can get the PWM. These are dedicated PWM pins. You can get, you want to control the brightness of the LED, you want to control the speed of the motor, then you have to generate the PWM pin. Any voltage of motor, like a 24 volt, 50 volt, 48 volt, any type of volt motor you want to control, then PWM, you can generate the PWM pin voltages at these pins. And by this pin you can control any other solid state device, like a solid SSD, solid state drive, and transistors, this type MOSFET. Okay, then you can get the PWM output, and then also, and after that you can control the speed of the motors. Okay, and there is 13 pin, there is one LED connected to the 13 pins, inbuilt LED. This is used, get it? It is just near to the 13 pin. You can see this is the inbuilt LED in the board for checking that the first LED program, the blinking operation, by checking it is communicating with your laptop or not. If it is blink example is running smoothly, fairly, then you can say that my Arduino controller is communicating with my laptop. If there is not any communication is there, then maybe there is problem with the board, or there is softwares or drivers. There's many problem. So it is suggested that you have to at first check the blink example in on the Arduino, then after you can make the circuit, like big circuit. Okay, and this is the ATmega 328 microcontroller. This is the main brain of this board. Atmel ATmega 328 PU. This is the microcontroller. The program, as you burn the program is burned in this microcontroller, and it will work as you want to work. Okay, this is the reset button. Why reset button is used? Anyone can say why reset button is used? Reset button. Why we use reset button?
Any type of program is pre-installed, it will be reset up.
Yeah, actually, if you suppose that there are 20 to 25, 30 lines of the coding, C coding is there. Okay, and your program is stuck in some loop, if loop, while loop, any loop, and you want it to start from the starting first line, then you have to reset. Then it jumps back to the first line of the programming, and programming starts from first line. So this is why this is the purpose why reset is used. Okay. There are many of the Arduino are in the market. You can see the Arduino Uno, Arduino Leonardo, Lilypad, Mega, Nano, Mini, Mini Pro, BT. These are the Arduino are depends on which application you want to make. If you want many more input and output, more analog input sensors as you require, then you can use the Arduino Mega. If you want less than Arduino Uno, at basic level where you want to start is the Arduino Uno. And in the training, we in the starting we have just start from the Arduino Uno. We will train the students, teachers from Arduino Uno because it's the basic board. Then after you can use the Arduino Mega, Arduino and different Arduino Robo, Arduino Lilypad. These are the different application specific Arduino, like Arduino Robot is used for robot. Okay, so this Arduino Uno is the basic board. From you can start at the beginning level. These are the getting started how we can you can note down the steps, because when you want start working on this you can face the problems. You can note down the steps that at first you have to download and install, but presently there is no need to install this software. You can also have only save these softwares. You can get this software from, you can write it arduino.cc. In the arduino.cc, in the and downloads, you can get the Arduino software. You can download it. Is free, it is open source. Okay, no need to pay. Okay, then connect the board to your computer via USB cable. Then you have to connect the board USB cable on the USB cable. Okay, launch the Arduino IDE. Arduino IDE is the first Arduino IDE where you can write the program, you can run the program, you can take the values, readings is the Arduino IDE. Then select the board, because I have explained earlier that many of the board, Uno, Mega, Lilypad, then you have to select which type of board you are going to use. Okay, select the serial port, serial on which serial port you are using, COM port 5, COM port 6, on which you have connected your Arduino. Open the blink example. I have explained earlier that you have to start from the blink example. Then when blink example is running properly, then you can use other program for other purpose and upload the program. Okay, at first you have to connect. This is the USB cable. Okay, USB cable, via USB cable you can connect to the your laptop. Okay, and then power is coming in the Arduino. Okay, Anurag, please show connect the one Arduino here with this laptop with via USB cable. You can see now. You can write down the steps, because these steps is important at the beginning level. You can get confused with the many of the steps, how my Arduino is not working, I have the problem. So you have to follow these steps. Okay, otherwise you will stuck in this. At first you have to open, this is the Arduino IDE. This you can see in the PPT. This is the Arduino IDE. Okay, Arduino IDE. You can see here. Here, this is the power is coming in the Arduino. You can see the board. It is connected to the USB cable. Now you can program it using Arduino IDE. Okay, Arduino IDE. हाँ, इधर यहाँ पे दिखा देना बीच में, लैपटॉप के सामने देना उसको कर लो. Okay, you can see here, this is the Arduino connected with the USB cable. Power is coming in the Arduino. Okay, this is the connected with the laptop. Okay, when I will explain the solar tracking project, you can understand all the components, how it is working. Okay, this is the first step, how to connect the Arduino. Okay, now you can see here the board. Please see the steps. At first you have to go to the tools, then board, Arduino Uno. You have to select the Arduino Uno. Okay, the tools, and then port. You have to select the port. Okay, port COM port 6. Here in your laptop where you have connected this the Arduino, it may be COM port 10, COM port 5, COM port 1. It depends on the your communication port of your laptop where it is connected. Okay, now the first example you have to run, it is the blink example. Okay, and you have to go to the file, then examples, You can write down the steps, file, then examples, then basics, then blink, because these are the necessary and elementary part of the Arduino programming. If you want to build a solar tracker or a robotic arm, then you have to know these steps. Otherwise, you are not able to make these projects, because this is the elementary bricks of the Arduino programming. Okay. This is the blink example. You can see here the void setup and void loop. Void setup and void loop is there. Okay, pin mode 13 output. Here we have defined it is a C programming, very simple C programming. You can see void setup, pin mode 13 output. You have defined the pin 13 as an output in the void setup. In void setup, you will write the line. You have to define only one time, and in void loop you will write the code which you want to repeat again and again. So these are the void loop. uh, in while loop, the digital write 13 high. At first you have writing it high, then delay for 1 second, then writing low and delay for 1 second. Mean it is a blink, high low in between 1 second delay. This is used for uploading the program. This one, the arrow, you can see the arrow. When you click the arrow, the program is uploaded in the Arduino microcontroller. And for the compiling, you can use this for only compiling the program. It will compile your program and check there is an error or not, and make a hex file. And this is used for the uploading the program, arrow key, and the program is uploaded in the Arduino microcontroller. Okay. If there is any error, it will show a red window down in the Arduino IDE. Yeah, hardware interface with the Arduino, because solar tracking is a hardware interface with the Arduino. Then you have to know the logic, on which logic it is working. You can see the input transducer, means it may be the pressure sensor, it may be the voice sensor, it may be the light, it, humidity, temperature, if anything you can use here. It will take the signals here, and analog, if there is analog inputs, then it will take the analog input from A0 to A6, or it is digital, then at the digital input of the Arduino. And then you can send it to the your laptop or computer, that you can check what is the output is coming out. If you want any algorithm, anything where you want to send the data, you can send. You can interface many advanced software like MATLAB and LabVIEW also with the Arduino. And the robotic arm, you can control the robotic arm with the Arduino microcontroller. Now this is Arduino programming basics, void setup and void loop. You can see only once executed. If you want to execute only one time, then you have to write in the void setup. You can see here in the blink example, void setup. This you can see the pin mode 13 output. We have defined the 13 as an output, because we want to blink it on and off, on and off. We are giving the command to the 13 pin. Okay, so it is working as an output pin. If we want to take the input, then is the input from the sensors, so it is output pin. So here I have defined it in the void setup only one time, and in the void loop executed repeating again and again, means I want it in the on and off, on and off, on and off. Okay, so you can see here in the void loop, digital write 13 comma high, it is high, then it is high for 1 second, because the delay is there. From after high, it is for 1 second delay, then 13 low, 1 second delay, and it is repeating again and again. Okay, please tell, if I write these lines, 4 lines in the void setup, what will happen? Anyone can answer? If I write these 4 lines instead of while loop in the void setup, then what will happen? It will blink only for one time, because in the void setup it will execute only once.
Get latched into the condition.
Yeah, only one time it will blink and then it stop. In the void loop, it will again repeat again and again. Blink operation is there. Now you can see here the if else condition, because in the solar tracking we have used the if else condition. These are the basic elementary parts of the programming you have to know. Okay, if else condition में इसमें if the analog values is greater than threshold value you can define like 5 volt, 3 volt, 2 volt. It depends on the condition of what you want. Analog value is greater than this threshold value, then digital write LED pin high, means the LED pin uh, will high. Okay, it the switch is on, switch is off, motor is on. Okay, else digital write LED pin low, otherwise the motor is off or LED will off. It depends on the if the analog value is greater than threshold. Same we have used in this solar tracker, that LDR1 value is greater than LDR2 value. Okay, then it will rotates according to the values. It will try to track to increase the value, to stabilize the value, means the on the both LDRs the value will be same. And when the stable condition, when the solar tracker is stopped, then all the LDR have nearly same values until it will keep rotating. In the demonstration you can see sensors. I have used the sensor, the LDR light dependent resistors. I have used sensors are used to detect the response to the electrical or optical sensors. I have used the LDR is the light sensors. Okay, the sensor convert the physical parameter like temperature, pressure, humidity in the electrical form. In the LDR we have used the LDR sensor with the potential divider circuit, 10k resistance means LDR and 10k resistance, and the output is taken from the combination, means from the potential divider. Okay, you can check the output from the potential divider and it will read by the Arduino. Then we get the output from the LDR. In LDR, when light is there, the this resistance is very less, around 100 to 100 ohms. And when the dark is there, if you put your hand on the LDR, then the resistance changes to 10k around. But there is large variation in the resistance of the LDR. And this is the thing we have used in the solar tracker. When the light is there, the resistance is different, and we are continuously reading the values of the resistance. Okay, and then we get the values are changing. If the LDR1 have the more value, LDR2 is the less voltages, then we rotate according to that. Okay, so this is the sensor we have used, the LDR4 LDR sensor with the potential divider circuit. And these potential divider circuits output voltage are A0, A1, A2, A3. You can write down in the you copy the A0, A0, A1, A2, A3. These are the analog inputs voltage, and I have connected one LDR with the A0. Second one x-axis one LDR with A0, x-axis second LDR with A1, y-axis first LDR with A A2, A0, A1, A2, A2, and y-axis second LDR with A3. This is the connection. And for reading of the voltage of the solar panel, I have connected with the A4. So 5 analog inputs are continuously read by the Arduino microcontroller. And you can also see on the laptop, you can also see on the serial monitor of the IDE. You can check the voltage, and you can also see in your mobile app, because the solar panel is on your roof and you don't want to go again and again and check the multimeter the voltage is coming or not. It is not a convenient way. This time you want all the thing on your mobile phone, all the internet, WhatsApp, Facebook, and values on your mobile app you want. Okay, so it is very important to get the technology in your app, mobile app. So I have added this, and I will also explain how you can add this. And I have also a video on YouTube channel. I will give you the link also, and you can learn many things, because in 1.5 lecture it is very tough to explain all the things. So you can learn from the YouTube channel. Okay, this is the LDR sensor. This it will change the resistance depend on the light. When there is light, its resistance is very less, around 100 ohm, 200 ohm. When there is the dark, it is 10 kilo ohm. So there variation in the resistance, so variation in the output voltage, and output voltage is read by the Arduino microcontroller. This is the criteria of the sensors: accuracy, environmental conditions, range. What is the range of the sensors? Calibration. Calibration should be good because a not calibrated sensor will give error values. Resolution is also important. The smallest value can it measure. Cost is also important. Okay, it will depend on where you want to apply it. Repeatability means always repeat nearly same values, not very varying values. So these are the criteria of the sensors. Now motors, you can see the motors I have used here in the DC motor, 12.5 rpm, 24 volt, and 200 milliampere rating DC voltage motor. You can write down if you interested, because if you want to make this project, then this specification is important. And you can also we can communicate for this. If you want, you can get any information. These are the motors. You can use the servo motor. I have made 6 degree of freedom robotic arm in my thesis topic, MTech thesis topic. It's a 6 degree of freedom robotic arm servo motor based. You can use the servo motor also, but in the servo motor the programming part is also increased. So in the DC motor it is less programming part. It also depends, you want to precise movement in the robotic arm in a pick and place. You want very precise movement. So you can use the servo motor, stepper motor, like printer. In the printer, stepper motor is used. Okay, CD drive stepper motor is used. Okay. So here I have used the DC motor. Okay. Now the motor driver. Why motor driver is used? Anyone can tell? Motor driver used. Why the existence of motor driver is there? Anyone can guess? Anything? Motor driver?
You can say to maintain the torque, to
Yeah,
first
yeah,
to achieve that torque, then
yeah,
maintain the torque
yeah,
speed to be
yeah,
maintained at an exact point.
yeah. You are achieving the point. Any question
Ye
from
point
the
is the torque.
centers? Till now, any queries from the center you can ask, ma'am, please. They can communicate. Okay. If any queries regarding Arduino controlling, programming, C programming components, till now the topic is covered. You can ask any questions, okay? And at the end we do the session on conversation of the question and answering, okay? Now the motor driver is used because Arduino will work on 5 volt, means digital outputs of 5 volt voltage, and this motor is 24 volt. Okay, then this is 5 volt and this is 24 volt. How it can drive this volt motor? Okay, it is not possible to drive a 24 volt motor with the 5 volt Arduino. So the driver is came. Driver will take the signals from the Arduino. Okay, 5 volt signal. It will convert in the amplified way, means 5 volt 0 volt signal will convert it into 12 volt 0 volt. Okay, and 0 volt 5 volt converted into 0 volt 12 volt. 5 volt 0 volt 5 volt 0 volt is converted into 12 volt 0 volt 12 volt 0 volt. And which motor you want to run, you can connect with the driver. You can see in the PPT here, you can clear the control input 1, it is from the Arduino microcontroller. Okay, control input 2 is from the Arduino microcontroller. Control input to the M2 from the Arduino microcontroller, and control input 2 to the M2 motor 2. This is for the motor 1. This is for the motor 2. Blue one is the motor 2. Green one is the motor 1. And the input 1 and input 2 is coming from the Arduino, which is 5 volt signal. Okay, which is 5 volt signal. It is controlling the motor of 24 volt. How? Here 12 volt DC is coming to the 8 number of pin. It will take the voltages here from here. Okay, it will check the input voltages from input 1 and input 2. It will sense the signal voltage. It is 5 volt or 0 volt or 0 volt or 5 volt, and it will convert the voltage and give to the pin number 3 and pin number 6. This is the working of the driver. So motor will start working. So and same here for motor number 2, input 1 input 2, motor 2, pin number 15 and pin number 10 takes the signal from the Arduino and it converts to the amplified signal and it will give to the motor M2. Okay, then motor M2 will start working. Okay, same here. Here Arduino is sense the signals from the LDRs. It will take the signal which LDR have the maximum voltages. Okay, then it will goes to the analog inputs of the Arduino algorithm. I have write the algorithm C programming in the Arduino. It will check the voltages, then it take the decision which motor have to move clockwise, which motor have to move anti-clockwise, how it will rotate to get the maximum benefit from the sun. Okay, clockwise or anti-clockwise, all the algorithm I have written in the coding. This is the coding part. Okay, then other is the controlling part. You can control, you can use the driver, you can use the MOSFETs, you can use the optocouplers. This is the optocoupler. Anurag, please. This is the optocoupler. If you want to control the high power motor, high power devices. Okay, white one, white color is the optocoupler. Okay, yeah, ma'am, please focus on this, because the if you want to control the power components like motors, high power motors. Okay, high power devices, this is the MCT2E. The number is MCT2E. You can write the number of the optocoupler MCT2E. Okay, it is a 6-pin optocoupler in which the pin number 1 I will explain in the next slide. Okay, this is the optocoupler used for optical isolation, because from the pin number 1 to and other pin there is no connections, electrical connection in the optocouplers. Okay, then and understand the driver IC. Okay, this is also the driver IC. This is the L293D driver IC. This is L298 driver IC. The difference is that it's the current rating. It will control 298. You have the more current rating, more heavy motor you can control, and L293 have less current rating, nearly about 2 amperes, and in 298 4 to 5 amperes you can control the motors. So these are the purpose is same. You can control the 2 motors simultaneously from the 293 or 298. Okay, this is the circuit. Yeah, you can also control the speed of the motor by using PWM. You can see in the PPT that this is 25% of duty cycle, 50% of duty cycle, 55% duty, 100% duty cycle. At 100% duty cycle the motor have maximum speed. At 50% duty cycle, half speed. And you can generate these PWM pin on Arduino pin number. At the PWM pin, which pins are PWM pins? I will explain. 3, 5, 6, 9, 10, 11. Okay, these 6 pins are dedicatedly for PWM purpose. You can directly generate the PWM on these pins and control the brightness of the LED. You can control the speed of the motors. You can control the using solid state drive triggerings. Okay, now the Bluetooth interface with the Arduino. Bluetooth, I have explained earlier that if you want to uh, take the current values, current real-time values in your on your Android app, okay, then you can use the Bluetooth. Okay, Bluetooth have 4 pins here: RX, TX, VCC, and ground. Okay, RX, PX, VCC, and ground. RX is the receiver one, TX is the transmitter one, VCC 5 volt, and ground 0 volt. Then you have to connect the RX of the Bluetooth to the TX of the Arduino. RX of the Bluetooth to the TX of the Arduino means when it send, it will receive, and this send, then Bluetooth will receive. Okay, then and VCC 5 volt and ground 0 volt. This is the connections you can see here, and this is you can check the real-time values on your Android phone. I will explain when I will show the demonstration of the solar tracking system, how you can get the values, okay, from the Arduino controller. This is the circuit diagram. You can note down in your notebook that this one VCC is going to the 5 volt. Okay, here you can see 5 volt. Okay, and black one is the ground. It is going to the ground. Okay, this one is the ground, and TX, this is the TX of the Bluetooth module is connected to the RX of the Arduino. Clear here? And RX of the Bluetooth module is connected to the TX of the Arduino. This is the connection. Okay. It will communicating with the Arduino. It will take and receive the data. Okay. A smart solar tracking system. Now we are coming to the smart solar tracking system. This is the solar tracking we have made in the innovation lab, our lab, and this is the solar panel I have used here. Solar panel, 4 LDRs are there. This one is the one LDR. Here is the second one, second LDR, third LDR, fourth LDR. In both axis, x-axis for 2 LDRs for x-axis and 2 LDRs for the y-axis I have used. And they takes the analog voltages data and giving to the Arduino microcontroller. Okay. This is the battery I have used, 12 volt battery. Here you can use the battery or adapter for power purpose. And motor driver IC. This is the motor driver IC I have used, motor driver IC, L298 motor driver IC, or you can also use the L293 motor driver IC. This is the Arduino microcontroller board. Okay. Description and working of the each component, how it is working. For example, you can here see here the two motors, driver A, motor A, driver B, motor B. Okay. Here microcontroller, FPGA microcontroller, you can use FPGA microcontroller, you can use PIC microcontroller, at Mega 328 microcontroller, any microcontroller you can use, and you have to make the logic according, and it will drive the driver I either here, driver A and driver B. Here I have which driver I have used, L293 motor driver. Okay, and it takes the signal from the microcontroller. Here I have used the Arduino. Okay, Arduino gives the signal to the driver A, and it gives the power voltages to the motors, motor A and motor B. Why I have used motor A and B? Why not motor C or motor A only? Why motor A and B? Because I am want to control the X and Y axis. So two motor is used for, one is for the X axis, other is for the Y axis. So it is X and Y axis. If you want to another axis and another application you want to add, then you have to add more motors. Okay, this is for the two axis. Okay, sensor is there. Solar rotation mechanism means programming of the solar rotation. I have said earlier, algorithm I have written.
Party that you have taken, like sensor you have taken,
Yeah.
power you have taken two stepper motor variations.
Yeah, sir.
Even LDR you have taken two ampere each.
Yeah.
So what are the components for?
It is nearly all the components we add, all the component cost. It is nearly 1500 to 2000 rupees.
Including the mounting structure?
Including this structure. If you mount to another frame, or if you want to improve it, then it will increase the cost. It is the basic structure I have used. Nearly 1500 to 2000 rupees it will cost. Okay, sensor rotation mechanism means programming I have made. Okay, now you can see the complete assembly of the system. This is the solar panel. You can also see on the hardware solar panel system. After lecture you can if you want something personally to check, or any component you can check, or you can visit our lab. It is in the NITTTR. You can visit, many of the projects are there running. We have some trainees, they are working on the projects, and we have some projects from the industries also. So if you want, you can visit our lab also, and you can take extra time to check what are the projects are going on, and you can get some practical knowledge more. Okay, and this is a panel. This is a gear and panel mechanism. Servo motor, here the servo motor is used. LDR sensors, microcontrollers, voltage regulators, which is used to regulate the voltage where 5 volt is needed or 12 volt is needed, charge controller, battery, base, and the pillar assembly. These are the all the hardware components of the solar tracker. Okay. Now optocoupler I have used. Why optocoupler is used? Anyone can say you are from electrical background, and optocoupler, where the need of the optocoupler, anyone can tell?
For the firing of the SCRs, basically the load for that.
Yeah, we can fire it for CR, but there's one thing is missing. The most important thing of the optocoupler.
Optical,
Optical rays.
Optical.
Isolation.
because we are working on solar system, so light radiation is required.
Yeah.
That is why
Yeah.
effect coupling is required.
Yeah, optical isolation is very important. So it is used for optical isolation, and you can see here. You can clear it. Okay, signal input. Okay, this is the input terminal. Okay, optocoupler, the white one. I have you have seen at the input terminal. There is one photodiode is there. It is a photodiode. It is inside of the IC. You cannot see it. Okay, you can see in the specifications and on the manufacturer's specification. You can check. It is the optical LED. Okay, and this is the ground. When the signal is come in the LED of then the signal IR is this IR based LED, and it goes to the photo transistor. Okay, it triggers the photo transistor, but there is no any electrical connection between them. There is no electrical connection between them, but it is controlling the photo transistor. Okay, if at this side, the photo transistor side, there is high power side, and there is some problem, there is some short or some heavy voltage is come, then there is no any effect on this portion, because there is no electrical connection, then there is no damage is there. So it is very important tool for optical isolation. So you can control via 5 volt voltage to 440 volt kilovolt of appliances. This is the advantage of the optocoupler. And we have a kit. We will show you the working also for this optocoupler. You can see the circuit diagram of the circuit for whole the optocoupler based relay control of Arduino. Why Arduino? This is the 5 volt signal is coming to the microcontroller board, Arduino microcontroller. This is the ground, and this is the connection output port. RB is 220, generally 220 ohm resistance to the IR base LED inside the optocoupler, and this is the ground. This will triggers the photo transistor here. If it is triggers, then the voltage is coming here, and it will switch the relay. When it will switch the relay, then it will control the AC load, bulb, motor, fan, anything, but there is no electrical connection between them. Here in the kit, we will show you a AC bulb triggering on off by the optocoupler and Arduino. Okay, when we demonstrate our project. Okay, this is our innovative skill e-learning YouTube channel. You can check the different uh, videos regarding any robotics, Arduino programming, controlling, optocoupler, and solar tracking system. Okay, these are the videos we have uploaded on in this channel. You can just write in the search innovate skill e-learning. If you will search in the YouTube, you get this channel, and 10 videos are uploaded, and you can see here 6,398 views. These are the views of our channel, and 106 subscribers. Okay, and this is all about our YouTube channel. You can check the video. We have the lectures in this YouTube channel. 1 hour lectures, 30-minute lectures, different variety of the lectures are there for Arduino programming. The complete lecture on the Arduino, how to program the Arduino with the Android phone. Different lectures are there. You can check on the YouTube. If you subscribe it, then you can get the notifications when we add the new videos in this. You can check. Okay. This is our Innovative Skill Facebook page. You can connect with Innovative Skill updates, the training, the programs, the R&D activities, the projects. You can connect with the our Facebook page. Then you can ask anything. You can communicate, because we are also provide the winter training, summer training. The 1 month summer training is going to announce. We will announce on the Facebook page also, and also on our website www.innovateskill.com. You can get the important notifications there when the summer training will start, because in previous year we have trained around 40 students summer training, and we have 5 trainees for different college: Punjabi University Patiala, Global Institute from Ludhiana. We have 5 to 6 training. If we want to train your student here, we will give you hands-on experiment, hands-on practical whole training here. And if you want also the workshop in your college, we will also ready to give a workshop practical training. Okay, this is the all about. Now I want to show you the video of and then also demonstration of this solar tracking. Okay, solar tracking system. Alternative driver IC. You can also see Bluetooth model. Right? आज के साथ कर लो. You can check the voltage is changing. It is 0.06 when there is no flash, and when there is flash it is 0.25, and in the sun natural light it is around 9 to 12 volt. It is try to face the 90 degree of the light. This is for anchor axis. Now we are going to demonstrate at first the optocoupler base. ऑप्टोकप्लर वाला करना ना, इस पे ही फोकस करना. पहले इसको कर लेते हैं, फिर अभी चेक नहीं है. ठीक है, ठीक है, इसको you can see This is the solar panel, and 4 LDRs are there. This is one is there. For x-axis, this is for the x-axis second one, and this is for y-axis, and this one is for y-axis. The 4 LDRs are there. 1, 2, 3, 4. 4 LDRs are there. Okay, and now you can see the total working of the this solar panel. Now I'm going to give a flash using by this yeah, now I'm going to flash. Okay, this is try to rotate it at 90 degree of this. If I am giving to the flash this at this, at one side is dark, one side is light, then it is rotating, and the movement and the x-axis. Okay, you can see I am hiding the light from the one to the one LDR and giving the light to the another one. It is rotating to the light. Okay, you can see here again. This is okay. We can vary the speed of the motor by using the PWM pin I have explained earlier, and you can see another. This is the movement for y-axis. Okay, this is for y-axis movement. Okay, you can see by hiding one and giving light to the other. Okay, this is the movement. Okay, because this is the LDR sensors, and these are very sensitive to the light, so you have to um, uh, calibrate it, and you have to check again and again in the coding part, then how it is working. Okay, you can check here as it is rotating. Okay, one side is dark, one side is light. Just keep on rotating. Okay, until it reach the maximum light. Okay, this is the total working of the project. Now you can see here all the components of this. Yeah, components. Yeah, you can see the components. You can see here the this is the Arduino Uno microcontroller board. I have said earlier, microcontroller board Arduino Uno, and this will take the signals, analog signal from the LDRs. This LDR, it will takes the signal. Now it will take the signals from the LDRs. These are the 4 LDRs are there for X, 2 LDRs for the X-axis and 2 LDR for the Y-axis. It will take the signal via potential divider circuit at A0, A1, A0, A1, A0, A1, A2, A3, A4. These are the input voltages taken by the given by the LDRs, and it will sense by the Arduino microcontroller, and it is continuously checking the voltage which LDR have the maximum voltage and rotate to take where the light is maximum. Okay, and now for the motor connection, this is the connection for the RX and TX for Bluetooth module. This is the Bluetooth module. This is the Bluetooth module. You can see here to take the real-time data in your Android app. Because it is very important that to check continuously your solar panel is generating voltages or not. If there is problem is there or not, because it is installed on your roof, then you can check the voltage on your mobile in your room. Okay. Now 3 and 5 is the controlling input for input 1 and input 2 to the motor driver. For motor 1, this is 1, this is 2, and this is 9. Here you can see the 9 and 11. It is for the another motor for two motor 3 and 6, 9 and 11. Here you can see here, and this one is for the ground purpose. This is the ground for the motor driver L293 motor driver and Arduino both. Okay. And this is the motor. You can see the motor is used. This two motor is used here. You can see here is 12.5 rpm DC motor 12.5 rpm DC motor, 200 milliampere, and here 24 volt. You can use 24 volt. This one is for the y axis, and this is for x axis motor. Okay. All the components are explained here. Now I'm going to explain. This is motor driver IC, L293 motor driver IC. You can see here. Uh, This is the motor driver IC, and you can see here the four inputs are there. One, two, three, four. Four inputs are there. Four inputs for the here you can see. You can see here four inputs are there for from the Arduino microcontroller to control the two motors. For two motors, there are four inputs for bidirectional motor control for forward and reverse. Okay, and this one is for 5 volt. This one is for 5 volt for the motor driver operating voltage, and this one is for the ground, and this one is for the motor driving motor 12 volt voltage. This is all about the components of the solar tracking system. Okay, if you want to add the power electronics component, optocoupler, SCR, track, you can add this. Now I'm going to demonstrate another project in which we have used the optocouplers, MCT2E optocoupler, by which you can control the high power rating components, motors, solenoid, relays. So, electronic. You can see here, and the circuit diagram also. You can see. This is the circuit diagram of this project, and at first I want to show you the hardware component. Okay, this is circuit diagram, and you can control it using the optocoupler. Optocoupler is there, relay is there, and there is a lamp. I am controlling the lamp by triggering the optocoupler using the Arduino microcontroller. Now I want to show you the hardware and all the components. You can see here. This is for input voltage, input triggering, controlling from the Arduino, and it is from the 13 number pin, and black one is the ground. Black one is the ground, and white one is from the 13. It gives the signal, input signal to the optocoupler at pin number 1, where is the IR LED is there. It on the IR LED, then IR LED gives the infrared sensors, infrared triggering to the optocoupler, photo transistor at pin number 3 and 4, and photo transistor on. When it will on, then it will on the relay and bulb is connected to the normally closed, normally open of NO of the relay. You can connect it with the NO or NC. It depends on your application. In the NC, the bulb is continuously on. When you give the input, then it will disconnected. It is off, and with the NO normally open. When you give the triggering voltage, then it will off. And in this project, I have connected it with the NO. Now normally open. When signals come from the Arduino controller board, then it will on the optocoupler, and then optocoupler controls the relay, and then relay controls the bulb. By using this, you can control any application like your AC fan and any AC component, high power component. There is no any electrical connection between the this bulb and the Arduino microcontroller. So it is very important, and it have applications in the industries also. So to make this to control the high power rating of the equipment, high power rating of the motors, and the relays, and high ampere rating of the appliances. This is all about the power electronics components application in the industries and to control the motors. If any you have any query, you can ask the queries from any centers. Any centers have the queries, you can ask anything about the Arduino controller programming components, circuit diagram, anything, any doubts. सर आप लोग भी देख लीजिए अगर आपको भी
Yeah, the participants से इसके बाद लिख दो, validation के बाद देख लेंगे because this. आ जाइए अभी बैठ कर कुछ भी किया जाएगा. So the participants here can come and see the circuit closer, okay? Once the validation is over, and we have all the centers connected here. So the main aim of this session was to just give you an insight on all the hardwares available, because we need not get afraid with the hardware. Whenever you speak about power electronics, one thing you have to remember is the power circuit and the control circuit, there should be an isolation. You can use pulse transformers, you go for optocouplers. So this is a very important thing. So I just wanted him, I told him, don't take big circuits and confuse them. Take a very simple circuit and just the concept of an optocoupler. So that is what he showed you at the end, that a bulb is there of a higher rating. You can just, this is a simple circuit he got, but whenever it is a higher rating bulb or any motor or drive or any system, when you connect a control circuit and a power circuit, there should be isolation. So that concept was shown to you with a very simple circuit. Okay. So anyway, I just ask the PPT. His PPT also we will share. So his circuit is available. You can also try at your end. Okay. So this is what, like, we have just come to the end of this course. And first of all, I would like to hear feedback from the centers. So I think all the centers are also connected. So let us first go to which center? This is, I think, Gate, is it? So Gate. Yeah, we want feedback from you. Like now we are almost on the end of the course. 5 days are over. So we would like to hear feedback from you. What did you like about the course, or what are the changes you require?
Good afternoon, madam.
Good afternoon. Good afternoon, sir.
Most of the practical oriented demonstrations are very good, and we have learned from that. And we are looking forward to more courses like that, so that we can have better knowledge of this, so that we can handle projects in a college or institute.
Yeah.
Thank you very much, madam, for such a course.
Okay. So you are from which college, which university?
I am from Gate Barampur. It comes under BPUT.
Okay. Yeah. Okay. Okay.
Thank you, madam.
Okay. Okay, sir. Thank you. Thank you for your feedback. And next. Gate Polytechnic. Yeah. Yes, sir. Yes, you can just give your feedback. I think we can go to the next center. Some problem is there with them. Which university is next? Yes? Kanchipuram, yeah.
Yes, it's helpful for us, ma'am. We're expecting more from you. In DC to DC, I want. Anyway,
okay, yeah, sure, ma'am.
Good, ma'am.
Okay. Yeah, we heard from you before also. Like the problem was, like, I just contacted many experts, But at the last time, many of them couldn't come. But my thing was like I just wanted with wind also, wind and fuel cell. I wanted a very good session. So there, like if you go for fuel cell, also many DC to DC converters were there, boost converters and all, and even in wind also, then AC to DC. But that session we couldn't get the expert properly. That was the reason. Otherwise, I just planned like that. Ki it should not only be solar; it should be wind and fuel cell. So mainly the like we couldn't go to the expert, like experts they confirm first, but at the end of the day because of many other things they couldn't come. So that was the thing. Like next time we will just we will make sure that we will have some alternative experts for the same topic. So that was a problem. Otherwise, if there are more experts in this, since this is a research oriented and in-depth topic, we don't get much experts also. Okay, so that was another thing. So anyway, next time, since was the first attempt for power electronics for renewable energy, this was the first attempt. So we also have gained many experience that what are the things we have to extract. Surely the next time when we do, we will try to give you a better input from our side. Okay, so
It's definitely it's helpful for us, ma'am. Thank you, ma'am.
okay, thank you, ma'am. Thank you. So next university, Eternal University. Yeah, Eternal University. Shall we hear from you? Yes? We can't hear you.
Hello? Hello?
Yeah. Yes, ma'am, we can hear you.
Everything at your end was excellent. But there are some programs in MATLAB that we were not able to understand. Actually, they were very complex, and also we were expecting more practical. And as you have told that you were not able to organize that expert regarding the wind energy, no? You have already given over there that you will give expert lecture on hybrid systems. So
Yeah.
we will be expecting more hybrid systems means wind and biomass or something else, hydro, etc. So we were looking for that also.
Okay. Yeah.
Everything else was very good. And that lecture you have explained yesterday about PSO and GA, that was very interesting. And today's solar tracking, these were very interesting lectures.
Okay. Thank you, ma'am. So we'll also try as I already told you that hybrid. There was a problem. We couldn't do it. So my main aim was also that key in that different other topics will be covered like AC to DC converter and all those things. We will try because mainly if you see any DC, any renewable energy, the concept is same. There you will be having a DC to DC converter and then a DC to AC converter. Only in the wind case, there is a difference that AC to DC converter is also there. But otherwise, what we have explained for solar, the same thing comes for even battery or for a fuel cell. Okay, so that portion I'm not worried. But wind was not like we couldn't go into wind. So next time we will just try that. We will include that also. And thank you for your feedback.
Thank
Okay,
you,
and
ma'am.
next, any other university, ma'am? PVP Siddharth University. Let us hear from you.
Good afternoon, ma'am.
Good afternoon, ma'am.
Myself,
Yes, we can hear
Hemlata.
you. Yes, ma'am.
Myself, Hemlata, ma'am. All the sessions are very informative, ma'am, especially on multi-level inverters. We gain a lot of knowledge. At the same time, whatever may be the algorithms you have explained yesterday, those are also very informative, ma'am. But they belong to selective harmonic elimination. What I feel is if you introduce some more modulation techniques, like
Yeah, sure.
uh, they will
PWM carrier.
PWM carrier. They will be helpful to us, ma'am. At the same time, the other university they have given the information from DC to DC converters. From choppers, we are inversion again back inversion. That if it is introduced, that will be more helpful to us, ma'am. Like the choppers to inverters.
Yeah.
And apart from this, all the sessions were very informative, and we gained more knowledge from the sessions. Whatever maybe you have covered the topics in the sessions, whatever maybe the topics you have covered, all are informative, and we gain a lot of knowledge. Thank you.
Okay, thank you, ma'am. Thank you for your feedback. And as ma'am again said, we just covered only selective harmonic. There are number of harmonics like SVPWMs. You have carrier pulse, multiple carrier pulse, and it is a vast area like sine PW. Many techniques are there. You have high switching frequency as well as the fundamental switching frequency. So you have a lot of techniques. I just, as I told you, I just covered only one portion. Like next time surely we will see that we will include more of these other PWM techniques also. And thank you for your feedback, because this is a very positive thing that we just want feedbacks like this. What are the other things we are expecting, so that next time we will surely cover all those questions. Okay, so surely all the PWM techniques also we will go in depth. The thing is, when we have multiple things, can't go inside one. Here I took SHE, and I was able to tell you, like, even if it is Newton Raps and GAPS or all techniques we were there. So when we go for multiple, then MATLAB simulation, we'll be able to tell you only the theory part. But as the suggestions was there, it is good. We will try to have converters like DC to DC converter for a full day, and what are the different algorithms which can be used for firing and all those things. Similarly for inverter. So we have also got a better idea that next time how to plan this course. Okay, so thank you for your feedback, and it was a very like good feedback from your side. And now let us also, I think all the other centers are over. One more is there. Which polytechnic, ma'am? Okay. Yeah, Gate Polytechnic. Yes, we can hear you.
Hello?
Yes.
Ma'am, I have a question to Alok.
Yes.
Hello? Ma'am, if this technique is used for solar panel, the cost is increased. So why we use this technique?
In which technique the cost is increased?
Solar
automatic tracking. That is mechanical tracking. Yeah. See, in the mechanical tracking, I already told you. Say mechanical tracking, as you said, cost is increased. I don't purely say that it is a thing, but still, if you go for Germany is one of the country which mainly concentrate on solar. There around 90% generation is from solar, and in Spain they have a very big solar plant also. There, if you go and see, they have used this solar tracking technique. So, okay, you can just go to the Discovery Science. They have given a very good, that was a very big plant. It can supply more than some 10,000 houses it is supplying. And they are extending that. So, there also they are going for this automatic tracking. Since it has some advantages. So the thing is, the power which it utilizes is very less. So that's why we were just talking with Alok also. Why don't we have this electrical and mechanical tracking together? So that was our idea. We shouldn't tell it here. We were just talking that because the advanced countries are using this technique. We don't say this is not a good technique, but we are just trying to have a technique where both electrical and mechanical tracking, so that electrical tracking will dominate and mechanical tracking only when it is required. Say when the sunlight is here, like towards the east, if the panel is towards the west, there is, so only when it is most required, most around 90% electrical tracking and 10% so that the power can be. So you can think about. So there are chance of a lot of research. So I was also talking with Alok that why don't we hybridize this and give a I shouldn't come out. We were just planning for some research in this area also. So many countries are using this technique. Okay, so this is not fully eradicated that it is using power, so it's not good. There are countries using it, so there are advantages. In this also, we have to see how to reduce this power consumed by the motor. Okay, because it is not fully running. Whenever whenever there is a change, because sunlight also at one instant it will not change. It is a gradual change. So might be an hour it rotates. It is not fully rotating. Yes, yeah, we want your feedback now. Or you have any other doubt, you can just ask.
Feedback is when this course is knowledgeable and having which full of theoretically and practically informations. And we glad thanks to you for the short-term course, and we continue with NITR Chandigarh for the future SPCs.
We are very thankful to you. This is the first time like electrical department you have connected. But one small suggestion at your end, every time your mic, your bandwidth, yeah. So actually, we got the information from the technical person here. She's telling that your bandwidth, there is some problem with bandwidth because we don't have problem with other centers. We can hear them clearly, we can see them, and your end that some bandwidth problem or some problem is there for the next course. Come with a better solution because yours is a government institute. You can do like hardware or jo bhi required hai, you can do it. So please, at your end, come with a better solution. Otherwise it was clear, like we can hear there is some small change required. So we expect you that next time when you come there should be no audio problem. Come with a better bandwidth, and if there is some problem in your hardware side also, you can just rectify. I don't think so hardware because it's a laptop or computer you're using, so there is, I think it might be the bandwidth. So please go for a better bandwidth. You should have a dedicated at least 2 Mbps speed dedicated for this course. Okay, so thank you for joining us, all the nodal centers also. And as I already told, please the coordinator send me the list of participants and the attendance register, the scanned copy of the attendance register on Monday itself. I should get from all the centers. That is one thing. And the other things, as I already told you, send me the bills, send me the hard copy of the attendance copy, and the receipt of your coordinator and ancillary bill, and all these things should reach me within the next week so that we can also process it. Okay, so thank you all the nodal centers, and let us hear the feedback from the participants here. जल्दी कर लिया, जल्दी छोड़ देंगे.
Very informative. We have learned many things. For us being electrical people, it was just some the thing was.
Deepika, इसको focus कर दो because they were participants were also very interested कि हमको देखना है.
It's well informative.
Okay. So did you learn something from this course? Yes. Okay.
But we wanted more other renewable energy sources.
Yes. Yeah. That mostly we covered on PV. So next time we can just try on that. Okay. Yeah.
One more thing I want to add into it. We have some short-term goals on the waste management, waste generation from the waste.
Okay.
Biogas waste. Because I have also an interest on waste energy generation from the waste.
I think civil department they go for this waste management and
energy generation from
the waste. Energy generation from
then simulation in the MATLAB using Arduino software. That is a must training for us.
Okay.
Because students keen to interest towards the new technologies.
Yeah.
And in these 5 days course, various aspects has been considered. Maximum power tracking, Arduino softwares are there, GS and PSO is there. And the smart grid technology is very keenful and very beautifully being explained in that days by Yokogawa persons. Very beautifully the aspects of clamp meter, multimeter, power scope orders. Very informative 5 days are there spent over here. And one more thing I want to add it. Give 1 week course on the wind and parallelly for the biogas generation from the biogas.
Okay.
That is must for us. If we have a bio waste material, we start getting energy from them. Either it is a small one, I know that, because no much energy is being generated from bio waste. But still, if we club with this Arduino software and MATLAB simulation, it will be very helpful for us.
Okay.
Okay. Definitely.
So there are some industry,
from their side.
Yeah.
They are preparing the things from the
so that's what he was telling. We will just
very small.
We have tested there, and in future.
We can just make a project for them so that it will be useful for us also. Because
we can extend the lectures of 5 days, these STCs on that technologies individually.
Okay.
For the PV, for the fuel cells,
okay.
For the wind, for the bio. Similarly on the geothermal and ocean energies also.
Okay, sure.
Thanks a lot.
So any other feedback?
First of all, a heartfelt thanks to CME for organizing this course. There are some matter of appreciation to the keynote speakers who have taken many of the topics. First of all, a matter of appreciation to CV Man for showing us the PhD cases of the 11 level oscillator. That is a new type of prototype she worked on it. And also it gave the initiative that we can work on the power conditioning systems of energy management systems. She also have given in-depth knowledge about the MPPT TV modeling with the MATLAB strategies. And although the multi-level inverter was core sector because that is the main ingredient of solar systems. Also, I like to thank the keynote speaker, Dr. Tilak sir. He has given us the view about the smart grid initiative that has been taken part. And the most powerful impact was how the power regeneration was captivated in that particular client he has spoken many words of. Also, I want to thank the keynote speaker from the Yokohama. They have delivered the most needful hour of the situation, that is power conditioning system. Everybody is working on generating the power, but conditioning of power and measurement of that has nobody has taken initiative on that. But Yokogawa has developed the devices by which the energy management system, the energy auditing labs, the most powerfully the removal of the harmony, which was also told by man, will be taken into counterpart because its measurements will be taken into counterpart, and initially the research will be in this sector. Also, I like to thank the senior, thank Mr. Kuldeep Singh. Yeah, he has given an initiative regarding the MATLAB simulation in the plug-in vehicle modeling of his MPTZ. So they were it was very new for me to hear about the electric vehicle because I never counterpart with such technology ever before. So it was quite improvising for me. Also, I like to thank Mr. Alok Dev. He has been working on multi-training system that comes to my field because I come from a renewable energy sector. So it is quite innovative project. Yeah, hopefully there will be implementation, as ma'am has said, Germany has taken account into it because it will be raising the performance level of the system. So optimization can taken into counterpart for this particular sections. Also, I like to thank the broadcasting team, the neutral, and above all my colleagues who supported for such a healthy environment so that it was very convenient for me to take up the lectures for 5 days. Thank you very much.
So any other feedback?
In the face of burgeoning energy crisis, I think this kind of short term courses plays very pivotal role. And unless and until we come across this kind of short term course, we cannot do anything because each person are separated from each other. There is no interlinking of things. So this kind of, I think, short term course gives us some insight, as to how we should go ahead to harness all these natural sources of energy, replenishable, which is replenishable in nature. Especially as far as environment condition is concerned, uh, I think all those conventional source of energy is creating a lot of problems in the societies. And so, especially, I think Simi Madam, if she has taken initiative to awaken, enlighten the, I think, faculty members from different institutes, and especially I came across so many faculty members who are trying their level best. But I think Simi Madam's contributions, I think she is dedication, I think, undivided attention and dedication she is taking towards this kind of short-term course. That I think will really go a long way to help the humanity, human civilizations, because it is not only confined to, I think, this study, but it has something to do with the civilizations also. Because I think world is suffering from two problems, and one problem I think that is pollution of the environment, global warming, and even beyond that, what I want, educational purposes, all this thing is necessary. But we also should try our level best not to consume electricity or any energy beyond what is required for us. Because in autobiography, Gandhi has said, we should not consume anything in our life which is not vital or indispensable for our health. In the same way, energy also, many times we see, there is no dearth of people's, having a lot of attention towards all these things. But when it comes to, using energy, they are not displaying any sort of, I think, seriousness from it. They are playing ducks and drakes with this electricity, electrical energy. I think we should try to consume as less energy as possible in our lives. That is also one way I think nobody is focusing on. That is a spiritual aspect of, I think, all these things. So thank you very much, madam. And in fact, I have been a slow learner, so I think 50% I understood, 50% it went out of my mind. So thank you very much, and I would keep on contacting with you, and I
Sure.
hope you will. I think, well, Rabindranath Tagore said very important thing. Where the knowledge is free, where the head is held high, where society is not divided by narrow domestic walls. So I think this kind of initiative will fulfill the dreams of, I think, our forefathers, especially I think Rabindranath Tagore type of person who wanted knowledge to be disseminated from one part of the world to the other part of the world. I think this kind of course will enlighten really the entire human being, and I think it will come to a great rescue to the humanities. Thank you, madam.
So I think we had heard from our participants also. So I would like to personally thank all the Knitter family, first of all, our ETV department. They are really dedicated, and you would have seen before, like, after lunch also they are there here first. In the morning also they are here first. So I thank all the ETV family here for coming and supporting us. So without them, this connectivity is not possible. The internet connectivity, the computer science department, and mainly the participants. And I can say in my full career, so many days, very enthusiastic participants we have got. So like they were so much interested to learn. That is the main thing. After 4 o'clock, also usually the ICT people they run away. They don't. We can't see them. But after that, also they come discuss with it, and they wanted to visit the lab. They came there. So really, it was a very good set of participants also. So first of all, I thank all the participants here and the participants at the nodal centers. Thank you for connecting us, and I just thank all the coordinators at all the nodal centers because they have also taken more effort in connecting and being with us, because there was a problem of holiday in between. Like first day was a holiday, so at the last moment all the course we have just shifted and we did a lot of change. Still all of them cooperated, so I thank all the nodal centers, the coordinators at nodal centers, and all the Knitter family and all the participants here for coming and making this show a grand success. And I have to even thank our experts here. They were also very good. They were just there with me whenever I call them, whenever I change. I say no, this is not the time. You have to take here, there. They are ready to take, because whenever some experts they say we are not coming, then I have to just call the experts here, local experts, and I have to change. So I first of all thank them also, they're being a support here, because without that their support nothing will happen. I was just taking like first day fully, and second day when I took the afternoon session, suddenly the expert couldn't come. So I just asked Kuldeep, his lecture was on Thursday, something you have to just shift, and he did it, because that is the spirit here at Knitter also. Whenever there is some change, we are there. There are people for helping us, so everything went smooth. Okay, so I thank everyone, even our students. They were also involved, our ME students. So I thank once again all of you, and all these PPTs. I too require a small break. That's why on Monday, I have asked one of the participants here to send me the like email IDs, and all the coordinators also have the thing. So I'll be just sending you all the PPTs. Some of the PPTs I have to get from some of the experts. Some of the experts have already given me, and my PPTs are also there. I'll be sending you all these details by Monday or Tuesday. You will be getting it. Okay. So thank you once again, and let us just distribute the